Good evening, students. As a famous mathematician has said, mathematics is not about numbers, equation, computational algorithms. It is about understanding. With this thought, I'll start today's session. My name is Soumya Ranjan Das, Director of Ethos Edu Solutions. And along with our today's speaker, Mr. Durgesh Pangeshkar, Director of IIT Prashikshan Kendra, I'll welcome all of you for today's Brainathon Excellence talk, exploring the fun side of mathematics. So today we are going to learn a lot of things about maths, about various equations, about various theories, about how maths can be a very easy subject, and most importantly, how maths can be a scoring subject for you all. So today, we are going to take a deep dive into mathematics, where Sir is going to take you through this journey. So first of all, I would like to welcome all the students and would like to name the schools who are participating in today's event. Uh, my voice is echoing, I guess. Is it clear now? Sir, am I audible?
Yeah, you are audible.
Okay. Uh, we have Army Public School Camp with us. We have Prodigy Public School. We have Kendra Vidyalaya number 1, 2, and Kendra Vidyalaya 9 BRD. We have Signet Public School. We have Klein Memorial. We have St. Vincent's. We have Pawar Public School, St. Arnold's, Innovera Public School, SNBP International School Wagholi, Bharati Vidyapeeth International School Lohegaon, City International School Vanori and Kothrood, Blossom Public School, the new branch Nare, St. Francis, Mount Carmel, Sihagar City School, Mother Teresa School, Orbis International School, Pushpa International School, Indra National School is again participating for the students who skipped the last one. So I welcome you all students, and I thanks all the school coordinators and principals to allow us and to make sure your students participate in today's event. So without wasting much of the time, I would like to hand over the session to Sir. Sir.
Yeah, thank you so much. Very good evening, students. Thank you very much, Soumya Ranjan, for a nice introduction. Thank you all these schools and the principals, teachers, and coordinators for encouraging students to attend this particular talk. So basically, the agenda for my talk today is to give you certain insights into this fascinating subject of mathematics. Probably lesser known to you, probably those facets of the subject which probably you're not fully aware about. So I will try to introduce you to some of those aspects of mathematics, the fascinating, interesting, intriguing, and beautiful part of mathematics. So probably after this entire this presentation, maybe it will be for an hour or so. We can also take questions, but more importantly, you would possibly get to understand mathematics or appreciate mathematics from a different perspective. So this is my objective, so that you will study it with greater enthusiasm, greater reverence, greater zest, and then it will naturally translate into better understanding, better ability to solve problems. At the same time, also better ability to get marks in the different exams that you might write, whether school exams or competitive exams. So let me run you through this particular presentation I have prepared, and then you will discover along the way what we are actually trying to do. Okay, so when we start. All right, I hope you are able to see this screen and also are able to listen to my voice clearly. So if there is any issue with you're not able to hear my voice or you're not able to see the screen, it says exploring the fun side of mathematics. That's the screen I am displaying. So in case you're not able to see it, yeah, fine. Everybody is able to see that. Thank you so much for the feedback. So this is going to be an interactive session. I would like your feedback on the chat box. My name is Durgesh Mangeshkar. So you will see Durgesh Mangeshkar host. You can send me your views and answers to whatever questions I'm posing during this course of the talk on the chat box. Yeah. So let's go ahead. At the outset, mathematics basically has three aspects. Okay, जैसे हम लोग कोई building बनाते हैं, if you see any structure, typically you will see that there is a foundation. फिर वो धीरे floor by floor the whole building is built. Likewise, mathematics is also like a skyscraper. Okay, so it's like a tower. So उसका एक foundation है जो काफी deep है और hidden है. जिसके बारे में जरा कुछ स्कूल में बात नहीं करते, कॉलेज में भी बात नहीं करते. When you go to university, they slowly start talking about the foundation. But what you basically expose in your school and college mathematics is basically pure mathematics and some aspects of applied mathematics. These two things are basically what are explored. Now, as per a great mathematician, Gauss, I don't know how many of you have heard of this mathematician. We'll talk more about Gauss also towards the end of this talk today. Mathematics is considered the queen of all sciences. Like physics is considered the king of all sciences, mathematics is the queen of all sciences. So why it is said that is because it's the foundation for all the sciences. And therefore, unless you learn mathematics, you simply cannot learn the rest of sciences or forget technology. So therefore, we'll talk today about these different aspects. Mainly, we'll focus about pure mathematics and applied mathematics, which is relevant for your school. And basically, in your school, most of the mathematics that you have studied, I believe you're all standard 7th and standard 8th students. So going towards standard 9th or standard 8th, right? So what else maths you have studied in your respective schools is basically arithmetic and little bit of geometry. So basically you studied addition, subtraction, multiplication, division operations, and then all that, whatever can be done from that. So you can do some simple calculations of LCM, HCF, prime factorizations, ratio proportions, some mensuration problems, like you have this finding the area of a surface, finding the volume of a solid or some regular solids and stuff like that. Problems on simple and compound interest and elementary problems where arithmetic can be used. So basically arithmetic is something which has been taught to you since you were going to preschool, school, whatever. But arithmetic is just the beginning. Okay, it's just a small part of the entire world of mathematics. So essentially, whatever you are going to be learning now, there's a lot of things of mathematics which you'll be studying in future classes. And in today's talk, also, I would like to give you some insight about the world of mathematics as a whole, as it concerns. Okay, so let's talk about that as well. Since you know arithmetic, let's start from what you know. तो जो आपको already पता है, हम वहां से शुरू करेंगे. वहां के थोड़े से interesting facts. Let me just give you. The first thing is, this is a very elementary fact which connects maths with English language. So if you were to write the different numbers from 1 to 999 in the English letters, let's say for example 54. If I write FIFTYFOUR, you will see that when you write down in English the letters from 1 to 999, the letter A never comes into picture. This you may never have noticed probably, but this is an interesting fact. The first time you hear the letter A is, or if you find the letter A, is when you write 1000. So 1000 is the first number on a natural number series where you will find the letter A coming in. The second interesting fact about this is the letter E, you will find it in every odd number. So whether it's 1, 3, 7, 5, 7, 9, 11, you'd see any odd number, you will always find the letter E there. Okay, this is something interesting. As far as prime numbers are concerned, 2 and 5 are the only prime numbers which end in 2 and 5. Other normally prime numbers cannot end in 2 because they will be divisible by 2. But 2 itself is a prime number. So it's the only even prime number, aisa bolte hai. And 5 also, as you are very familiar, last digit 5 agar ho, so you immediately can recall that 5 will divide that number. But 5 itself is a prime number. So 2 and 5 are the only prime numbers. 2520 is the smallest number which can be divided by all digits from 1 to 9. So this is the smallest number which will find that 2 divides it, 3 divides it, 4 divides it, 5. So this 2520 is divisible by all the numbers from 1 to 9. So this is the smallest number. There are many such numbers, of course. Any multiple of 2520 also will have this property. But there are many other numbers which may not be multiples of 2520, but still they will be such that that they will be divided by 1 to 9. But this is the smallest number. So this is an interesting quiz question which you can possibly find somewhere in some exams as well. 18 is the only number which is twice the sum of its digits. So if you add up the digits of 18, what do you get? 1 plus 8 is 9, and 18 is twice of that. This is the only number in mathematics which satisfies this property. 26 is the only natural number that can be placed between a perfect cube and a perfect square. So 26 is between 25 and 27. 25 is a perfect square. 5 squared is 25. 3 cube is 27. So 26 is the only number which is sandwiched between a perfect square and a perfect cube. ऐसा कोई दूसरा उदाहरण numbers में नहीं है. No other number is Just before that number, you will find a perfect square, and immediately thereafter, a perfect cube or the other way around. ऐसा कभी नहीं होता. So this is a unique property of the number 26. Now 10 raised to 100 is called a number by the name Gugol. So it's called Gugol. So like for example, 10 raised to अगर हम 6 करते हैं तो you get 1 million. 10 raised to 9 करते हैं तो you get 1 billion. But if you do 10 raised to 100, you get a very huge number. 1 followed by 100 zeros is called a Google. In fact, a Google search, hum log jo karte, this name of this company, Google, also is after it also. Actually, the name of Google's company is not Google, it's Alphabet, but Google is the trade name, right? So Google name was motivated from this word Google, something very large, very huge. So huge amount of data it churns and searches out information for you, right? Google does that. So that's why this is name is motivated also from a number. So this is the largest number probably you may be aware of. There's one more, of course, a twist to this. If you do 10 raised to Google, 10 raised to 10 raised to 100, it's called a Googleplex. So that's another very, very large number. But that's the very, very unimaginably huge number. It's more than the number of atoms in the universe, it seems. Another interesting property you'll find is number 336. These will like thousands of properties of thousands of interesting numbers. Okay, this is not the only one. I'm just motivating the thought. So you can now do your own research. You can do your own Google search and find out more such interesting, exciting examples with interesting properties, interesting numbers with interesting properties. So these look at this 336 number. Somebody has discovered this property of this 336. 3 plus 3 plus 6 plus 3 squared plus 3 squared plus 6 squared plus 3 cube plus 3 cube plus 6 cube. So 336 is one of the very few numbers which satisfies this property. There are other such numbers, but I'm just showing you some of the interesting examples. So you will find amazing properties of different numbers. One such amazing number is also this. Okay, before I go to that interesting number which I'm coming to, look at this particular part. This is also some fun with numbers. If you do 1 into 1, you get, of course, 1. 11 into 11 is 121. But 111 into 111 is this interesting number, 1, 2, 3, 1. Look at the symmetry of numbers. You actually do this calculation in your calculator or really do it, you'll see that you get these numbers. So if you look at any of these numbers, equal number of ones to be multiplied from each other, by each other, you get these symmetric numbers. Similarly, on this side, you see something interesting happening. So these are interesting patterns. And you'll find thousands of examples of such amazing patterns and symmetry with numbers and fun with numbers on the internet and in different books. You can discover some properties yourself and have fun with numbers. So this is all arithmetic. Okay, I'm still in arithmetic. I'm still on your home ground, what you already are supposed to know. This is one interesting number of which Ramanujan had. It's named after Ramanujan. It's called the Hardy-Ramanujan number. So there are various versions of the story, but one such story is like this, that Ramanujan wasn't well. So he was being taken to a hospital, and he was being taken to a hospital by his own professor who was in the UK. His professor's name was Professor Hardy. So he was taking him to the hospital. On the way, Ramanujan sees one taxi, and the taxi has one number plate on it. It has a number, and that number plate had this number, 1729. So he asked Professor Hardy, Professor, do you know what this number speciality is? He said, no, I don't know. I'm just wanting to take you to the hospital. So he said, this is the smallest number which can be expressed as the sum of two cubes in two different ways. So there are many such examples of such numbers. This is called a 1729. So if you see 1 cube plus 12 cube, 12 cube is 1728, plus 1 is 1729. 9 cube is 729. 10 cube is 1000. So if you add up the two, you get 1729. So this is the smallest number, it seems, which can be expressed as sum of two cubes in two different ways. Now, if you see other examples of the similar Hardy-Ramanujan number set, you see 4104 is also one such number. You can also express this 13832. Theoretically, there are infinite such numbers which exist, but the smallest number was this. And the remarkable property of this number was brought to the world by Ramanujan in this particular conversation. So this number has become famous as the Hardy-Ramanujan number. Now, let me ask you a question. Let me ask you this question. What is the smallest number which can be expressed as the sum of two squares in two different ways? Any answers to this? You can't hear us? Okay, let me see. Is my voice audible or not audible? Can somebody reply? Are you able to hear my voice? Or is there any problem with the voice?
Sir, it's completely audible.
It's completely audible, right? Okay, okay. Fair. Thank you so much. Oh, some student just mentioned that, so I thought, is there any problem for everyone? All right. Now, let me come back to this question. Ramanujan found out this number, right? The sum of two cubes in two different ways को express करने के दो तरीके का smallest number is 1729. And there are other examples as we saw here in this box. Now my question to you is a quiz question. The smallest number which can be expressed as sum of two squares in two different ways. ये कौन सा है? Any guesses? 16. 16 को आप दो तरीके से कर सकते हो क्या? 65. Very good. Gatik Kumar. Somebody by the name Gatik Kumar has got it very correct. 65 is the correct answer. 65 can be expressed as 8 squared plus 1 squared. That is one way. Second is 7 squared plus 4 squared. So again, you will get 65. So this is the smallest number. 65 is the smallest number which can be expressed as sum of two squares in two different ways. Okay, so this is something interesting. One more interesting fact I would like to put up, which is a lesser known fact. Ramanujan, of course, is a prodigy. Ramanujan is a well-known mathematician. I'm sure all of you know it. There's a movie made of after Ramanujan. A couple of movies I know of Ramanujan also made. But another lesser known but equally talented mathematician was Dr. Kaprekar. He's also an Indian mathematician. And there's a very famous number by the name Kaprekar constant. Now let me talk about that. You take any 4-digit number whose digits are not all identical. So you take something like 3, 4, 5, 6, 1, 2, 7, 4, something like that. Don't have 5, 5, 5, 5, 5. Take any 4-digit number whose digits are not all identical. What to do? You're supposed to rearrange the digits in such a way to generate a largest number and a smallest possible number out of those 4 digits. So as an example, let's take this number 3141. Okay, the largest possible number possible from this using these 4 digits, it's 4311. Correct? And what's the smallest number possible from this these 4 digits? 1134. Am I right? So this is the smallest number possible. So what Mr. Kaprekar is saying is, you generate two largest and smallest number, subtract the smallest from the largest, okay, and then keep repeating this process. And once you keep repeating this process, at some point you will see that the process stops, which means you keep getting the same number again and again. That number is called a Kaprekar constant. So look at this 3141. Look at what happens. If I generate 3141 ka 4311 and I do minus 1134, the smallest possible number, I get 3177. Again, I repeat the process. Out of 3177, I generate the largest possible number, 7731. Smallest possible number from 3177 is 1377. I subtract this from this, I get 635. I keep doing this. Finally, this whole series stops at 6174. Interestingly, you take any other 4-digit number. कोई भी और 4-digit number लीजिए जहां पे all digits are not all identical, ना बस यहाँ पे fail होता है. बाकी you take any other 4-digit number and you do this process, you will find that 6174 पे ही process stop होता है. This 6174 is called the Kaprekar constant. So this can be a good magic trick. You can play with your friends who are not so mathematically inclined. कि उनको बोलो कोई भी 4-digit number लीजिए, largest minus smallest करते रहिए. Finally जो भी number आपको आता है आपके मन में रखिए. And then you can guess this number because you know that number is going to be a Kaprekar constant 6174 for sure. So this is an interesting thing. उसके पीछे कोई mathematics है. I would not get into that because थोड़ा complicated है. For 7th and 8th level समझ में नहीं आएगा. But at this is something interesting. This at least this trick or this basic property of the Kaprekar constant, I'm sure all of you can appreciate and understand. Even for 3 digits, there exists a Kaprekar constant. Now, let me present that. 495 is a Kaprekar constant for 3 digits. तो अगर आप जैसे 4 digits के लिए 6174 is a Kaprekar constant. For 3 digits, it's 495. Interestingly, there is no such Kaprekar constant for 5 digits, 6 digits, 7 digits. So these are only 2 examples which is there, and this can become a good basis for a lot of magic tricks and teasers for students to play amongst each other or to anybody whom you want to trouble. So essentially 4174 is 6174, I'm sorry, is the Kaprekar constant amongst 4-digit numbers, and 495 is the Kaprekar constant for 3-digit numbers. I leave it to you now to do your own homework. Try out this, see whether it really works or not. And if it works, it's a wonderful problem. And I tell you it works. That's why I'm presenting it. So this is called the Kaprekar constant, a lesser known mathematician. But nevertheless, a very talented one from India, Dr. Kaprekar's constant. Okay, now let's move on. There's something else which is there. Now let me first play this joke, which I don't know how many of you will understand. You read this particular statement. There are 10 types of people on earth, those who understand binary and those who don't. You would say there to 2 ही हो गए ना, 10 कहाँ से आ गए? So basically now whatever number system we use, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these 9 digits or these 10 digits which are there, this is called the decimal number system. So the base is 10. But you need not necessarily have that, right? You are well aware now in computer science, where the switches can be on or off, or low voltage, high voltage, where there is a binary logic. Only two things are possible for electronic circuits. So it's more convenient to design computers along the binary number system. And for some programming, may not be at a very fundamental level, but slightly higher level programming, use the octal number system or the hexadecimal 16-digit number system. So octal number system will have just digits from 0 to 7. Hexadecimal will have just from 0 to, we can't say 15, from 0 to 9 is 10 digits, that A, B, C, D, E, F are used as additional digits. So these are different number systems. See, this decimal number system is believed to be discovered in India, and this is a brilliant number system. So now we are using it so often that we feel it is very natural, but as a nahi, there is a big genius and there's a tremendous thought which has gone behind why 10 should be used as a base for counting and not something else. You can have number system to any base, not just these 3, 4 which I have presented here, binary, octal, decimal, because these are used. Octal number system was used in the early microprocessors for computers. Hexadecimal was used for little more advanced microprocessors. Binary is the machine code language, still 0 1s. So therefore, ये जो joke का अर्थ क्या है कि बाइनरी नंबर सिस्टम में ये 10 क्या होता है? 10 binary is in decimal. This is why basically this is what how you should understand the joke. So यहाँ पे दो ही लोग तरीके के लोग हैं, ये बोल रहे हैं, लेकिन ये जो नंबर है 10 ये decimal में नहीं binary में express किया है. So we are all familiar with what the decimal number system is, but essentially let's say a number like 45. This 45 is in decimal number system. This number looks in binary as 101101. So this is how it looks like. So my point is, I'm not getting into I'm not going to teach you how to convert decimal to binary, binary to decimal. This is not a teaching class for now. So I leave that for you to again learn in your school and your other classes. But there is a way to express numbers in different number systems. This is something which you all should know. Sometimes this fact is less emphasized in your school mathematics. So I just want you to be alert and appreciate that. जो हम लोग use करते हैं वो decimal number systems. But you can even create a new number system with a base of, let's say, 36, 87. If you like 2022 as a number, you can have a different number system with 2022 as a base. Nobody can stop you from doing that. You can generate infinite types of number systems, but some of them may be useful, some of them may be intuitive, some of them will match natural life more easily, some may not. So the decimal number system has got some consonance, some resonance with some natural aspects, and that is why, and it is very intuitive, it's very easy to use, and that's why we study decimal number system. But please remember, that's not the only number system which exists in mathematics. There are infinite numbers possible, and depending on the application, we might use one or other of them. Like the hexadecimal and octal were never used earlier, but when the advent of computers happened, they started seeing merit in using these number systems for utilization in different domains. All right, now let me ask you a simple question. This is just a simple brain teaser. I want quick answers from you. What's the answer to this question? If 1 is 2, 2 is 8, and so on and so forth, then what is 5? No answers? Ashutosh is saying 50, Manasvi is saying 50. Okay, good. So 50 finally, right? 50 is right. What is the answer? It was simple, na? 1 is 2, 2 is 8. तो कैसे आया है, जनरेट किया है? ये जो भी नंबर लेफ्ट हैंड साइड में है उसको स्क्वायर करते हैं और उसको 2 से मल्टीप्लाई करते हैं. तो 1 squared into 2 is 2, 2 squared is 4, into 2 is 8, 3 squared is 9, into 2 is 18, 4 squared is 16, into 2 is 32. Likewise हम 5 squared करते हैं तो 25 आता है, उसको 2 से मल्टीप्लाई करेंगे तो कितना आएगा? 50. So answer is 50. Simple one. So this was a very simple quiz. इसके आगे के quizzes थोड़े और thought provoking रहेंगे, so I am alerting you right away. Okay, so calculation tricks, methods, ये सब तो चलते रहता है. So this is always there, numbers and the fascinating part of numbers, their interesting properties, all that is definitely arithmetic. This is definitely a part of mathematics. And whatever school methods are used or taught to you, they are very important because they will work in almost all situations. So therefore, traditional methods which are taught in school must be learned properly so that you can utilize them in almost all situations. Vedic mathematics offers amazing tools for quick calculations. So बहुत सारे interesting tricks of calculation Vedic mathematics से आते हैं. लेकिन एक बात बताना चाहूंगा, हमेशा Vedic mathematics will not be efficient more efficient than traditional methods. हमेशा नहीं होगा. In some special situations, Vedic mathematics will give faster answers as compared to traditional methods. So therefore, traditional method को कभी छोड़ना नहीं. ये मत सोचो कि हम सब कुछ Vedic mathematics से कर सकते हैं. By the way, Vedic mathematics नाम की चीज ऐसी कुछ होती नहीं है, but एक 1930s में एक सेमिनल किताब एक शंकराचार्य जी ने लिखा था, compilation of various शास्त्रास. तो वहां पे उन्होंने जो भी ट्रिक्स दिए थे उस बुक को या उस ब्रांच ऑफ थॉट को उन्होंने वैदिक मैथमेटिक्स करके पॉपुलराइज कर दिया है. The real fundamental postulates of Vedic mathematics are still not well understood, but it is currently being used for calculation purpose. So हम लोग भी वही term use करेंगे. Another way to do it is abacus. Abacus offers tools to do quick calculations. So essentially, that is also another tool which many of you must have joined abacus classes when you were children. Almost have seen your friends doing it. It's a Chinese tool to do quick calculations. Again, it works very nicely, wonderfully for many situations, but not in all situations. Sometimes it can become more tedious than our traditional methods. So by and large, these are three different popular techniques which you should know. But you know what is the fastest way to calculate? The fastest way to calculate is using a calculator. तो से सर ये तो फिर चीटिंग हो जाएगा. नहीं, एक्चुअली ऐसा नहीं है, बिकॉज ओके स्कूल के एग्जाम वगैरह के लिए तो नहीं करना है ये सब, लेकिन आगे आफ्टर यू गो टू आफ्टर 12th स्टैंडर्ड के बाद आप जाते हो, इवन 10th के बाद भी आगे जाते हो 11th में, तो आपको कैलकुलेशन के लिए लॉग टेबल्स दिया जाता है. तो लॉग टेबल्स के साथ आप कैलकुलेट कर सकते. हाउ टू यूज लॉग टेबल्स वो बाद में पढ़ाते हैं. तो एक लोगैरिथम करके कंसेप्ट है मैथमेटिक्स में, उसके ऊपर एक लॉग टेबल्स आते हैं, उससे फास्ट कैलकुलेशंस होते हैं. तो 11th में ये देते हैं आपको. फिर 12th के बाद बोलते हैं लॉग टेबल्स की भी जरूरत नहीं है आपको, तो प्रॉपर साइंटिफिक कैलकुलेटर समझ देते हैं कि आप ये यूज कर लो. यू डोंट नीड टू कैलकुलेट इन योर ब्रेन. So after 12th, actually for higher studies, you will never need to calculate yourself much. Very elementary stuff you will be requiring. Basically, आपको concepts पता होने चाहिए, ideas आपके होने चाहिए, and understanding होना चाहिए. Then you will be able to do mathematics very comfortably. Calculation is not something which is required to be done by humans anymore. इसके लिए computers है, calculators है, number crunchers है. For that, you don't need to worry too much. Of course, for your school stuff, for your college, it's definitely advisable that you should learn mathematics, how to calculate here itself. All right. Now let me teach you some simple tricks from these Vedic mathematics and all these other tricks, how to basically do the calculation. Suppose you want to multiply two-digit numbers. Let's say you want to do 12 into 34. So one trick says that you just multiply the two extreme numbers, 1 into 3 here and 2 into 4 as 8. And as far as the intermediate number is concerned, you can get by cross multiplication like this: 1 into 4 plus 2 into 3. How much is 1 into 4? 4. And 2 into 3 is 6. So you get 10. So this 1 gets carried forward here, and you get 3 plus 1, 4. So 408 is the quick answer for 12 into 34. You can use traditional method also, but the Vedic mathematics method can be faster sometimes to get this particular stuff. Now, let me look at another trick for you. When you have to multiply by 11, for example, our traditional method is like you do this kind of stuff for doing 45 into 11 for that matter. But Vedic mathematics says just write 4 here and 5 here at the extreme and add up the two numbers and you get 9. And that's the basic final answer. So if you want to multiply any two-digit number by 11, utilize this trick. You don't have to do anything further. So let me give you one more example of this. Look at this 32 into 11. So what you need to do, just write 3 here and 2 at the extreme. Just add up 3 plus 2, you get 352. That's the answer. So multiplying by 11 is so simple by Vedic mathematics. I want to suppose do square of a number ending with 5. Okay, so 35 square karna hai aapko. So what will you do? You write 25 here and you do 3 into 4 as 12 here. So 1225 is the answer, the square of 35. So what to do? जो भी 5 digit से 5 से end होने वाला number होगा उसको square करिए and 3 जो भी दूसरा number होगा आपके 10th place में उसको next number से multiply करिए, तो 3 into 4. So likewise 45 square कितना होगा आप बताइए मुझे quickly. 35 square तो बता दिया मैंने. 45 square कितना होना चाहिए फिर according to this logic? Tell me the answer. What should be 45 square? Yeah, 2000. Neer is correct. 2000. Ritvik is correct. 2025. Neha is also right. Yes, Adesh. 2025. Because 45 square करना है तो 5 square to 25 हो गया. 4 into 5 करेंगे तो 2025 होता है. That is the correct answer. Now one more last thing. Suppose आपको 999 से multiply करना है किसी भी 3 digit number. If you want to multiply any 3 digit number by 999, there's a quick trick. just subtract 1 from this number, whatever number you want to multiply with, and you get 233. Write that as the first 3 digits of this number. And then 1000 को 234 से subtract करो. So whatever, if you get by 1000 minus 234, that is 766. Write down that as the last 3 digits of the number. So this is going to be the answer for any 3-digit number multiplied by 999. So these are some of the tricks which are there. इसके पीछे mathematical base है, लेकिन ये tricks करके calculations के लिए use किया जा सकता है. But as I mentioned and as I warned you, don't think that this will be ubiquitously useful. मतलब सब जगह useful होगा ऐसा नहीं. ये कुछ special situations के लिए ये tricks का इस्तेमाल किया जा सकता है. Otherwise आपके traditional method से काम में आएगा. या worst case में क्या आएगा काम में? अपना calculator आएगा. आजकल mobile phone पे आपका calculator आएगा. But I want you to understand that calculation definitely is the first step. Arithmetic is the first step for mathematics. तो उसमें आप अपना mentally जितना आप खुद कर सको अच्छा रहेगा, ताकि हमेशा तो आपको devices पे निर्भर रहना नहीं पड़े. लेकिन mathematics सिर्फ arithmetic पे या calculations पे नहीं रुकता है. This is just the start of mathematics. Mathematics की दुनिया बहुत बड़ी है, मैंने जैसे आपको कहा, and now I am going to tell you something more about it. Before I introduce you to the bigger world of mathematics, let me quote some of the famous statements by great mathematicians. Shakuntala Devi, our Indian calculation prodigy, she has said, what is mathematics? It is a systematic human effort to solve puzzles posed by nature. Very interesting way to put it. So it's not calculation. Mathematics is not about calculation. Mathematics is कि आप दुनिया में कुछ प्रॉब्लम देख रहे हो, उसको सॉल्व करने के लिए एक ह्यूमन इंटेलेक्चुअल एफर्ट अगर दिया जाए सिस्टमैटिकली, तो एक मैथमेटिकल फॉर्म लेता है. उसको मैथमेटिक्स बोलते हैं. नेचर इज रिटन इन मैथमेटिकल लैंग्वेज. दिस इज अल्बर्ट आइंस्टाइन स्टेट. Go down deep enough into anything and you will find mathematics. This is one great philosopher has said this. Another mathematician has said something very interesting which will be especially useful. जिनको mathematics difficult लगता है, अच्छा नहीं लगता है, वो आप ये पढ़े. Mathematics does not complicate simple things. Instead, mathematics makes complicated things simple. ये fact है. और एक statement है John von Neumann का. He is one of the founder fathers of computer science. He has said one hilarious statement. He has said that if you feel mathematics is complicated, then probably you are not experienced or seen life enough. Life is far more complicated. तो ऐसा बोला है. तो definitely ऐसी बात है जो गडर साहब ने कहा है, correct है. Mathematics does not complicate things. It actually makes complicated things simple. Because real natural phenomena जो चलता है दुनिया में, जो भी आप अभी स्क्रीन देख रहे हो, आप मेरी आवाज सुन रहे हो, इसमें जो भी मैथमेटिक्स इन्वॉल्व है इस पूरे टेक्नोलॉजी में इतना कॉम्प्लेक्स है, लेकिन जो एक्चुअली मैथमेटिकल इक्वेशंस इसको रिप्रेजेंट करते हैं वो काफी सिंप्लीफाइड रहते हैं, सिंपल रहते हैं. और अगर वो भी आपको कॉम्प्लिकेटेड लगे तो भगवान बचाए आपको. लेकिन पॉइंट ये है. So this is first part about mathematics. Now let me come to the fundamental part of mathematics. Now here I'm going to ask you some questions. Please answer that on the chat box. My question to you is this: because origin of mathematics कहाँ से हुआ? In counting principles. To count करने के लिए, measure करने के लिए, इसके लिए. So my first question to you is, what is a number? Number का definition आप बताइए. What is the definition of a number? You tell me what's a number. Write it on the chat box. आपका number का समझ क्या है? Numerals, okay? बोलिए, बोलिए, लिखो, जो भी लिखना है लिखो. Fixed quantity, used to count, okay? An integer. आगे. Keep saying whatever you feel. It's a numeric. It has numerical values. Numerals is a medium to counting object to express something. Very good. Okay, integer, okay, word or symbol, it's a way of language. Okay, calculating, it's a count. Okay, it's used to express magnitude. Very interesting. Okay, 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 fine, fine. So basically everybody has some idea of number, right? Good, good enough, good enough. Thank you so much. Second, this is the fundamental definition given in your school textbook somewhere, maybe in first standard, second standard. आपको याद नहीं होगा, कभी ना कभी आपके algebra के या maths के एक कॉर्नर में ये टेक्स्ट बुक में ये आंसर ये लिखा था. बिकॉज आपको भी नंबर्स के बारे में बताता हूं. आपको बचपन में बताया गया था टू काउंट फ्रॉम 1 2 3 4 लाइक दैट, है ना. बाद में बताया गया कि नहीं भाई, जीरो नाम की चीज भी कुछ तो होती है. फिर आपने फिर जीरो को भी एक्सेप्ट कर लिया, हाँ जीरो होता है. देन एज यू वेंट इनटू थर्ड स्टैंडर्ड और फोर्थ स्टैंडर्ड, यू आर टोल्ड नहीं, देयर आर सम नेगेटिव इंटीजर्स आल्सो व्हिच एग्जिस्ट. देन यू आर टोल्ड दैट नॉट इनफ, उसमें फिर बीच में फ्रैक्शंस भी रहते हैं. And then fractions are of two types, or those fractions and those decimal point में जो express करते हैं, there are two types. Those which can be expressed as a upon b, and those which you cannot be expressed as a upon b kind of form. So basically those are rational numbers and irrational numbers. So basically there are terminating non-recurring numbers. There are some of them are non-terminating but non-recurring numbers also. So ये तीनों combinations हैं. So irrational numbers कौन से रहते हैं? They are non-terminating, non-recurring. Are you getting what I'm trying to say? And there are something called non-terminating and recurring also. तो वो भी rational सी. So then we were told that negative integers है, फिर fractions है, fractions में rationals होते हैं, irrationals होते हैं. फिर बाद में शायद अभी by this time 7th में आपको इतना पता चल गया होगा कि सातवीं this rational irrational मिला के एक real number system generate होता है. As you go later in 11th standard, you will be told that इतना ही नहीं है, real number के साथ एक imaginary number system भी होता है. Real and imaginary दोनों x axis y axis जैसा चलता है, उसको दोनों मिला के complex number system बनता है. Then if you study mathematics even deeper thereafter, if you go into first year, second year of your university education, after 12, you'll be told that नहीं complex number सिर्फ इतना नहीं है, और भी बहुत सारी चीजें हैं. There's something called quaternions, then there's something called octenions, then there's something called cardinal number set. ऐसा आगे 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 नंबर का concept refine होते जाता है. तो इसलिए मैं आपको पूछ रहा हूँ what is a number. तो आपको बताया गया है कि number is a point on a number line. बट आप ध्यान से सुनिए, आपको कहीं ज्योमेट्री में बताया गया था कि पॉइंट इज एक्चुअली अ डिमेंशनलेस, साइजलेस, शेपलेस एंटिटी. तो नंबर इज पॉइंट इज जस्ट वो डायमेंशन ही नहीं उसका, कोई साइज ही नहीं है उसका. इस पॉइंट मतलब बिंदु जैसा है, बट है लेकिन है भी नहीं टाइप्स. तो नंबर अगर पॉइंट है, लेट्स से फॉर एग्जांपल आई से नंबर 3 है ऑन अ नंबर लाइन, तो नंबर 3 ऑन अ नंबर लाइन को पॉइंट बोलेंगे आप. तो पॉइंट है किधर? बिकॉज उसका डायमेंशन तो है ही नहीं, साइज है ही नहीं. तो एग्जैक्टली आप पिन पॉइंट कर सकते हैं कि नंबर 3 ऑन अ नंबर लाइन नहीं कर सकते. सो नंबर इज अ पॉइंट ऑन अ नंबर लाइन, ये तो एक्चुअली गलत डेफिनेशन, बिकॉज पॉइंट इज अ डायमेंशनलेस, साइजलेस एंटिटी. तो है ही नहीं. सो नंबर इज समथिंग ऑन अ नंबर लाइन, इट डजंट एग्जिस्ट. ऐसा कैसे हो सकता है? सो आपको कहीं ना कहीं the textbook has kind of fooled you if you really see. Now let me ask you, let me motivate this thought a little further. Number 3 के बाद कौन सा नंबर आता है? What is the number after 3? Tell me what is the number after 3? बताइए. Let me see. 4. नहीं 3 के बाद 4 कहाँ आता है? रियल 3.1. ओके 3.01. अच्छा 3.2. क्यों 3.2? 3.001. क्या? हाँ कितना बार? 0 कितने बार आएगा? तो 3.0000 कितना? अरे बाप रे, इतने बार 0 लिखा. ठीक है. तो बेसिकली डू यू सी 3 के बाद का नंबर आप डिफाइन कर सकते हैं क्या? 3.000 कितने बार 0? इनफाइनाइट टाइम 0 और उसके बाद 1. यू कैन नॉट डिफाइन अ नंबर आफ्टर 3. कैन यू डिफाइन अ नंबर बिफोर 3? 2.99999 कितने बार? इनफाइनाइट टाइम. यू कैन नॉट डिफाइन अ नंबर बिफोर 3. अगर आप 3 के बाद का नंबर डिफाइन नहीं कर सकते, 3 के पहले का नंबर डिफाइन नहीं कर सकते, तो 3 को कैसे डिफाइन कर सकते हैं? और 3 as a point on a number line आप बोलते हो, और point doesn't exist. It's a dimensionless, sizeless entity. It exists also, doesn't exist also. So number is what? थोड़ा एक mysterious concept नहीं लगता है क्या 3? तो मैं आपको ये बताना चाह रहा हूँ, not tease you further. It's 2 plus 2 obvious. ये मैं आपको पूछना, 2 plus 2 is equal to 4, ये obvious है क्या? 2 और 2 4. हाँ अगर 2 चीजें बताई मैंने, एक मेरा मोबाइल फोन है और एक मोबाइल फोन है, 2 और है और 2 है, सब मिला के 4 हो गए. या 2 स्टूडेंट्स है और 2 स्टूडेंट्स है, 2 ऐड होके 4 हो गए. सर 2 plus 2 4 तो ऑब्वियस है. हाँ अगर ये डिस्क्रीट काउंट करने के लिए अगर आप नंबर्स को यूज कर रहे हो, उसको डिस्क्रीट नंबर्स बोलते हैं, तो बेशक 2 plus 2 is 4 ऑब्वियस है. लेकिन अगर नंबर इज अ पॉइंट ऑन अ नंबर लाइन, या नंबर इज समथिंग टू डू विद अ नंबर लाइन, तो 2 plus 2 4 ये ऑब्वियस नहीं है. बिकॉज 2 plus 2 3.999 भी हो सकता था, 2 plus 2 4.001 भी हो सकता था. बिकॉज 2 नहीं है, जस्ट 1.99 के पहले और 2.01 के पहले के बीच में का कुछ तो एक रीजन है. सो प्लीज अंडरस्टैंड, रियल नंबर इज नॉट अ पॉइंट ऑन अ नंबर लाइन, इट्स अ फजी रीजन ऑन अ नंबर लाइन. ये एक इंटरेस्टिंग कंसेप्ट है, मैं आपको बताना चाहता हूँ. ये इसका थिकनेस, अगर आप स्मार्ट हो तो आप पूछेंगे सर वो उसका रीजन का थिकनेस क्या है? द थिकनेस ऑफ द रीजन इंटरेस्टिंगली it depends on which mathematical expression you are using. उसका कोई यूनिवर्सल थिकनेस भी नहीं होता. So basically what I am trying to say is, नंबर अगर आप डिस्क्रीट नंबर्स करके देखते हो तो काउंटिंग के लिए उसका इस्तेमाल जब तक हो रहा है तो बड़ा सीधा साधा है, सिंपल है. लेकिन नंबर अगर एक कंटिन्यूअस स्ट्रीम ऑफ नंबर्स, रियल नंबर लाइन की पार्ट का नंबर देखते हो तो नंबर ऑब्वियस चीज नहीं है. मैंने आपको थोड़े पहले बताया ना कि 3 नहीं है, 3 के आगे का नंबर हम डिफाइन नहीं कर सकते, 3 का पहले नहीं कर सकते, तो वैसे 2 के बाद का, 2 के पहले का हम डिफाइन ही नहीं कर सकते. सो 2 नहीं है. 2 इज अ फजी रीजन, 1.999 और 2.001 के बीच में का कुछ तो रीजन को हम 2 बोलते हैं, ये पूरे रीजन को 2 बोलते हैं, प्लीज अंडरस्टैंड दैट। और वो रीजन का थिकनेस कौन से मैथमेटिकल एक्सप्रेशन में, वो लॉगरिथमिक एक्सप्रेशन है, एक्सपोनेंशियल है, ट्रिग्नोमेट्रिक है, अलजेब्राइक है, क्या है, उसके हिसाब से उसका थिकनेस डिफाइन होता है फॉर दैट पर्टिकुलर एक्सप्रेशन। ये बहुत ही हिडन फैक्ट है रिगार्डिंग मैथमेटिक्स। देयर इज अ वेरी फेमस बुक, a very seminal book on logic and foundations of mathematics, written in around 1930s, 1940s में, by a famous mathematician who won a Nobel Prize by the name Bertrand Russell. He didn't win a Nobel Prize for maths. Maths के लिए कोई Nobel Prize नहीं होता. He won a Nobel Prize for peace. But he has written a book, Bertrand Russell's book. उस बुक में, वो बुक बहुत बड़ा है और डिफिकल्ट टू रीड बुक है, 750-800 पेजेस का बुक है. But after 300 pages in that book, Bertrand Russell has proved 2 plus 2 is indeed 4. 2 plus 2 is equal to 4 का rigorous mathematics proof 300 पेजेस का है. आप बोलेंगे सर क्या पागलपन है, 2 plus 2 4, मुझे पूछ लेते, मैं बता देता उसको, इतना 300 पेजेस का काम करने की जरूरत क्या थी. नहीं जी, डिस्क्रीट नंबर जब तक है तब तक 2 plus 2 4 ऑब्वियस है, लेकिन अगर रियल नंबर सिस्टम में अगर 2 plus 2 4 करने की बात आती है, ये प्रोफाउंड कंसेप्ट है. मैं आपको ये सब क्यों बता रहा हूँ, जस्ट टू टेल यू, जो आप जानते हैं वो भी चीज में बहुत सारी गहराई छिपी हुई है जो आपको अभी तक पता नहीं है, वो जरा सा उस पर जरा झांकने के सोचना शुरू कर दीजिए. समथिंग वेरी इंटरेस्टिंग अबाउट होल नंबर थिंग. सो नेक्स्ट टाइम यू थिंक अबाउट नंबर्स एज अ कंटिन्यूअस रियल नंबर सिस्टम, नो दैट इट इज अ सोफिस्टिकेटेड सिस्टम. ये कोई ऑब्वियस चीज नहीं है, एंड इट्स अ फजी रीजन ऑन अ नंबर लाइन, इट्स नॉट अ पॉइंट. प्लीज अंडरस्टैंड दैट, बिकॉज़ हैड इट बीन अ पॉइंट, you could have, that is, it doesn't exist because it is a dimensionless, sizeless, shapeless entity. It doesn't exist. So ऐसा तो नहीं हो सकता. So it is a region. और उसका thickness is very cleverly defined depending on the mathematical expression. So as now that you have listened to this presentation, इसके आगे आपका जिंदगी में नंबर का concept अलग होना चाहिए. Now और मोटिवेट करता हूँ थॉट टू अंडरस्टैंड कि कुछ तो और डीप चीज है. फॉर एग्जाम्पल, ये एक फेमस पैराडॉक्स है, इसको समझ पाए तो ठीक है, नहीं समझ पाए तो छोड़ दो, डोंट वरी. ये थोड़ा सा डीप है. आप में से जो सुन रहे हैं उनमें से कुछ प्रतिशत बच्चों को ये बात समझ में, दिमाग में थोड़ी बत्ती जली तो अच्छी बात है, इसलिए मैंने स्लाइड डाला है. नहीं समझे तो छोड़ दो. Zeno's paradox is a 3,000-year-old paradox. It's a Greek paradox. It says that which is in locomotion must arrive at the halfway stage before it arrives at the goal. मैं थोड़े सीधी भाषा में बोलता हूँ कि अगर कोई एथलीट है, उसको रेस कंप्लीट करना है, लाइक फॉर एग्जांपल एक एथलीट यहाँ से शुरू करता है, उसको ये रेस कंप्लीट करना है, so that athlete will have to complete at least half of this race to complete this, isn't it? और उसको ये हाफ कंप्लीट करने के लिए उसको ये हाफ तो कंप्लीट करना पड़ेगा, उसका मतलब उसको ये हाफ भी कंप्लीट करना पड़ेगा. So therefore he will never complete the race. So Zeno's paradox says that an athlete will never complete the race. For that matter, मैं अभी लेक्चर खत्म करने का कोशिश करूंगा, अभी 1 घंटे का लेक्चर है, my lecture will never get completed because to complete my lecture I have to reach half of that particular stuff. To reach that half I have to reach again further half of that. तो ये ऐसा कभी होगा ही नहीं, because half करते जाएंगे आप तो जीरो तो कभी बनता ही नहीं है. तो ultimately you will never be able to reach from one point to the other. So there will be no motion possible, motionless हो जाएगा सब कुछ. ऐसा कुछ उसका अर्थ है ये जीनोस पैराडॉक्स का. कुछ समझ में आई बात, कुछ बत्ती जली तो ठीक है. अगर ये पैराडॉक्स अप्रिशिएट नहीं कर पा रहे हो तो छोड़ दो. बट ये जो चीज है, अगर आपको थोड़ा समझ में आया कि कुछ तो गड़बड़ है, हाउ विल एन एथलीट कंप्लीट द रेस? ही हैज टू कवर हाफ ऑफ इट. टू डू दिस half he has to cover further half of it, or further half of it, further half of it. So ultimately we'll never be able to complete the race. ऐसा एक पैराडॉक्स, इंटेलेक्चुअल पैराडॉक्स पोज किया है. उसका रेजोल्यूशन कम्स इन सम कंसेप्ट कॉल्ड कंसेप्ट ऑफ लिमिट, जो मैंने आपको थोड़ा पहले बताया था नंबर्स के बारे में, फजी रीजन है वगैरह वगैरह, एंड 2 plus 2 is equal to 4. इसमें भी एक कंसेप्ट ऑफ लिमिट छिपा हुआ है. ये आप बाद में जब थोड़ा सा और पढ़ेंगे तब समझेंगे, लेकिन ये कंसेप्ट ऑफ लिमिट याद रखना. ओके, दिस इज नॉट एन इंग्लिश वर्ड, इट्स एन इंटरेस्टिंग थिंग. इस जेनोस पैराडॉक्स का रेजोल्यूशन भी एक मैथमेटिकल सीरीज में आता है, जिसमें एक इनफाइनाइट सीरीज बनता है. वो इनफाइनाइट सीरीज का एडिशन आप करेंगे तो सरप्राइजिंगली ये 1 आता है. तो ये हाफ प्लस 4 प्लस 1/8 प्लस 1/16 आप करते जाएंगे इनफाइनाइट टाइम्स, तो दैट नंबर जो आता है समेशन, it tends to 1, comes close to 1, sufficiently close to 1, and that is called the limit tends to 1. ये जो LIM लिखा हुआ है यहाँ पे, LIM, ये लिमिट का फुल शॉर्ट फॉर्म है. Okay, I have motivated the broad thought. Now let me tell you what is this world of mathematics about. There are 2 types of mathematics. One is discrete mathematics, second is continuous mathematics. Continuous mathematics is born from the real number system. Discrete mathematics is born from the whole number system. कि जो काउंटिंग पर्पस के लिए हम लोग यूज करते हैं वो ये है. तो सेट थियरी, परम्यूटेशंस, कॉम्बिनेशंस, प्रोबेबिलिटी, स्टैटिस्टिक्स, ये काफी हद तक डिस्क्रीट मैथमेटिक्स से जन्मा हुआ है. अभी आप कंप्यूटर साइंस में जो थियरी ऑफ एल्गोरिदम्स करते हैं, डेटा साइंस पढ़ते हैं, ये सारे फील्ड्स का एप्लीकेशन आपको डिस्क्रीट मैथमेटिक्स का एप्लीकेशन करके आप पाएंगे। बट बाकी का मोस्ट ऑफ इट मैथमेटिक्स आप जो पढ़ते हैं वो कंटिन्यूअस मैथमेटिक्स है। तो अरिथमेटिक, अलजेब्रा, ज्योमेट्री, ट्रिग्नोमेट्री, कोऑर्डिनेट ज्योमेट्री, कैलकुलस, वेक्टर्स, ऑल दिस इज बेसिकली born from continuous mathematics और रियल नंबर सिस्टम से मोटिवेटेड। आप पूरे आगे साइंस करोगे, सपोज आप इंजीनियरिंग करोगे, आर्किटेक्चर करोगे, बायोटेक्नोलॉजी करोगे, तो आपको पूरी तरह से ये कंटिन्यूअस मैथमेटिक्स पर ही निर्भर रहना पड़ेगा। इफ यू वांट टू गेट इनटू द वर्ल्ड ऑफ इकोनॉमिक्स एंड फाइनेंस, यू विल हैव टू रिलाई हेवीली ऑन कंटिन्यूअस मैथमेटिक्स, प्लीज अंडरस्टैंड। तो ग्राफ्स वगैरह ड्रॉ करने पड़ते हैं, इक्वेशंस लिखने पड़ते हैं, ये सब चीजें, पूरा चीज कंटिन्यूअस मैथमेटिक्स से मोटिवेटेड है। सो यू शुड नो अबाउट। सो लेट मी गिव यू सम इंटरेस्टिंग examples of application of discrete mathematics. Let me ask you a question. What is the probability? कोई पार्टी में जाते हो, let's say, अब 25 लोगों के पार्टी में जाते हो, there are 25 people in the party including yours. Okay, what is the chance या probability in terms of percentage? आप मुझे बताइए, 10% chance, 20%, 30%, जो भी आपको लगता है. What is the probability that any two people in that group of 25 will have the same birthday? क्या लगता है आपको, कितने लोगों का बर्थडे सेम होने का? एटलीस्ट 2 लोगों का बर्थडे सेम है, कोई तो 2 लोगों का बर्थडे सेम होगा, इसका क्या चांस लगता है आपको? 25 लोगों के बर्थडे पे गए आप, टोटल 365 डेज है कैलेंडर में, तो एनी टू सम 2 पीपल विल हैव द सेम बर्थडे, इसका चांस आप बताइए। लेट मी सी हाउ मेनी ऑफ यू कैन गेस दिस। ओके, 4% चांस, 1% चांस, 2% चांस, ओके, 6%, 8%, 21%, अच्छा कोई 50% भी बोल रहा है, इंटरेस्टिंग, 0.25, okay, very good, very good. So very generally most students are thinking that there's a very less chance, isn't it? 2%, 1%, 3%, 5%, 10% chance. You know what the answer is? Look at this. This is what discrete mathematics tells you. In a room with 23 people, well, 25 se bhi kam, 23 people, there will be exactly 50% chance of at least 2 people having the same birthday. But it seems in a room of 75 people, there is a 99.9% chance. Now this is very interesting. Suppose you go to any group, कोई भी ग्रुप, आप क्लास में जाइए, स्टूडेंट्स हैं, आप कोई पार्टी में जाइए, आप कोई भी जाइए, जहाँ जाइए, जहाँ पे एक 75 लोग हैं, या अराउंड 70-75 people are there, you can be almost 100% sure that at least 2 people will have the same birthday. आपने अपने क्लास में भी एक्सपीरियंस किया होगा स्कूल से, I don't know what is the strength of each class in your school, but 30-40 बच्चों में भी आपको काफी बार ऐसे देखा होगा कि 2 लोगों का बर्थडे सेम है, कोई तो 2 लोगों का बर्थडे सेम होगा। तो ये this is the graph which actually plays out. So if you see, 23 itself, it crosses the 50% mark. So at 25 it goes higher than that, and by the time it touches almost 70-75 people in the room, you will find that the probability is almost 100% chance. मतलब you can confidently guess in a group of 50-60 people that कोई तो 2 लोग definitely रहेंगे जिनका बर्थडे सेम है। So this is इसका मैथमेटिकल प्रूफ डिस्क्रीट मैथमेटिक्स से, परम्यूटेशंस कॉम्बिनेशन से आता है। अगर आप परम्यूटेशन ठीक से पढ़ेंगे तो सिंपल लॉजिक यूज करके इसका रिजल्ट आता है। ये कोई बहुत डिफिकल्ट प्रॉब्लम नहीं है, ये इजीली आप सॉल्व कर सकते हो, खुद अपना लॉजिक लगा के भी कर सकते हो। These are some of the interesting discoveries called a birthday problem. Now I am motivating one more thought to you called geometric sequences. This is a famous story. I am sure you must have heard of this story. Story is that the inventor of the chess, कोई तो एक राजा था और किसी ने तो चेस का गेम इन्वेंट किया। वो चेस का गेम इन्वेंट करके राजा महाराज जी को दिखाने के लिए गए। तो राजा साहब बड़े खुश हो गए कि अरे वाह, क्या बढ़िया गेम बनाया आपने, आपको क्या रिवॉर्ड चाहिए, क्या गिफ्ट चाहिए? तो उसने बोला मुझे तो सिंपल गिफ्ट चाहिए, लेकिन वो जो गिफ्ट मैं देना चाहता हूँ शायद आप दे नहीं पाएंगे। तो राजा बोला कि क्या बात कर रहे हैं, मैं तो राजा हूँ, मैं कुछ भी कर दे सकता हूँ, तुम बताओ तो सही क्या चाहते हो। तो बोले कि देखो मेरा चेस बोर्ड है, चेस बोर्ड इज एन 8x8 स्क्वायर, तो मुझे थोड़ा सा गेहूं या चावल जो भी था उस किंगडम में, तो मुझे ग्रेन्स चाहिए चावल के। तो फर्स्ट इस जगह पे चेस बोर्ड के फर्स्ट स्क्वायर पे 1 ग्रेन दे दीजिए, उसके दूसरे वाले उसमें ट्वाइस ऑफ दैट दे दीजिए, 2 दे दीजिए, उसके बाद 4 ग्रेन्स, 8 ग्रेन्स, ऐसा करके मुझे वो पूरे 64 ग्रेन्स बोर्ड्स को भरने लायक उतना ग्रेन मुझे दे दीजिए, मैं खुश होकर तृप्त होकर चला जाऊंगा। तो राजा जी बोला ओके कोई बात नहीं, वो मिनिस्टर को बोल दिया कि चलो दे दो उसको जो चाहिए वो, एंड ही वेंट बैक टू हिज चेंबर। आफ्टर सम टाइम द मिनिस्टर केम टू हिज चेंबर, द किंग इज वेरी शॉक्ड सेइंग दैट राजा जी हमारा पूरे किंगडम का सारा गेहूं खत्म हो गया, लेकिन ये साहब ने जो मांगा है वो हम दे नहीं पा रहे। बोले क्या बात करते हो, ऐसे कैसे हो सकता है? So this is a story, and the king was shocked. He said, "I'm very sorry, I cannot honor my word. I cannot give you that much amount of grain." Now, what is happening? What is happening is this: at first square में 2 raised to 0, मतलब 1 grain होगा, then 2, then 4, and ऐसा करके the last square will have 2 raised to 63 grains, and that's a very huge number. Such a huge number that if you add up all the grains of the whole world also, it doesn't really add up to what is the requirement. So basically, this is the power of geometric sequence. Geometric sequence मतलब आप कोई भी number लो, the next number in the sequence you can generate by multiplying it by some constant number, whatever constant. और यहाँ पे 2 था, so first number कौन सा था? 1 था, तो उसको next number कौन सा है? You multiplied by 2. Like that, the next number is multiplied by again 2. So 2 is the common ratio for all the subsequent numbers of the geometric sequence. So you can do 1, 3, you can multiply by 3, that means 1, 3, 9, 27. ऐसा भी एक हो सकता है sequence. Infinite number of geometric sequences you can generate. But this is a mathematical story. Reality पे हुआ कि नहीं मुझे पता नहीं, but this is often well-known fable, which is basically narrated to tell you the power of geometric sequences. अभी आपने arithmetic में शायद ये चीज पढ़ा होगा, तो 2 raised to 64 का नंबर कितना बड़ा आता है पता है? कितना आता है? 1.844 something into 10 raised to 19, मतलब 1 के आगे 19 zeros लगे, इतना बड़ा वो नंबर आता है. So therefore it's a huge number which you get 2 raised to 63. So geometric sequences. So one of the applications of geometric sequences is what you know as a compound interest. तो compound interest भी अगर आप first year, second year, third year का अगर आप formula लगाएंगे, 1 plus r by n the whole raised to, 1 by r by 100 raised to n. So I'm sure all of you know what is the difference between compound interest and simple interest. So Einstein had said that this is the 9th wonder of the world. What is the 9th wonder of the world? Compound interest is the 9th wonder of the world. He was referring to that. So why it is a compound this thing, वो बाद में आपको पता चलेगा. लेकिन there's a very famous rule which was given by Albert Einstein, and it's called the rule of 72. What is the rule of 72? It says that suppose you put your money in a bank and the bank gives you an interest rate of, let's say, R, that if you divide 72 by R, you get some number, and that is the number of years to double the money. So suppose आप एक बैंक में पैसा डालते हो और उसमें suppose 4% interest rate है, 4% interest. So if I ask you in how many years your money will get doubled, then you should do 72 divided by 4. You get 18, right? So 18 years में आपका पैसा double होगा because it is giving you 4% interest. But suppose you put your money, let's say, in another instrument where the interest rate is, let's say 9%, then 72 divided by 9 is 8. So in 8 years, your money will get doubled in that 9% interest rate. So यहाँ पे उदाहरण दिया है 3% interest rate का, तो 72 divided by 3, 24%. ये सिर्फ इन्वेस्टमेंट के लिए नहीं, आप ये पेरेंट्स को जरूर बताइए आपने कि रूल ऑफ 72 मैंने आज के लेक्चर में सीखा है कि आपको कोई भी इंटरेस्ट रेट है तो 72 बाय दैट करने का, तो आपको नंबर ऑफ इयर्स में पैसा कितना डबल होगा पता चलता है. दिस इज फॉर इन्वेस्टमेंट. इवन व्हाइल यू आर पेइंग ऑफ लोन्स आल्सो दिस कैन बी यूजफुल अनलेस यू आर डूइंग अ रिड्यूसिंग बैलेंस थिंग. तो ये रूल ऑफ 72 वाज गिवन बाय अल्बर्ट आइंस्टाइन, बट इसका डेरिवेशन करते वक्त लोगैरिथम्स का इन्वेंशन हुआ एंड ये नंबर ई का इन्वेंशन हुआ. आपने नंबर पाई सुना है ना, पाई 3.14822/7, आप पाई आर स्क्वायर्ड करते हैं एरिया ऑफ अ सर्कल वगैरह. सो पाई जैसा एक स्पेशल नंबर है मैथमेटिक्स में, वैसा ये ई भी एक स्पेशल नंबर, इसको ऑयलर नंबर बोलते हैं ई. सो ई का वैल्यू 2.7828 कुछ तो आता है, बट इसका डिस्कवरी ये प्रॉब्लम को, कंपाउंड इंटरेस्ट का प्रॉब्लम सॉल्व करते वक्त अल्बर्ट आइंस्टाइन जी ने किया था. तो ये इंटरेस्टिंग स्टोरी है जिसको समटाइम्स लेसन नो. लेटर ये जो ई है, ये नंबर ई का डिस्कवरी एक अलग प्रॉब्लम से भी निर्माण हुआ है. आप बोलेंगे सर ये कहां से आते हैं सब, ये सेंटा क्लॉज जी है, यहाँ पे चॉकलेट्स है, इसका और ये लेटर ई का क्या संबंध हो सकता है? है संबंध. लुक एट दिस पर्टिकुलर प्रॉब्लम. लेट मी एक्सप्लेन द डिरेंजमेंट प्रॉब्लम टू यू फर्स्ट. द प्रॉब्लम इज दिस कि एक चॉकलेट बॉक्स है, ओके, हैविंग असॉर्टेड चॉकलेट्स, अलग अलग तरीके के चॉकलेट्स. ये चॉकलेट्स को हम बाहर निकालते, चलो ये दोनों में से कौन सा पसंद आए आप चूज करिए, दोनों असॉर्टेड चॉकलेट्स के बॉक्सेस. Let's say I remove all the chocolates and I place them back, but I place them in such a way that none of the chocolates go back to the original place where it was. Are you getting it? Now, how many ways can I do it? Let's say there were n such chocolates, n chocolates were there. In how many ways can I derange them? Derange them matlab put them back in such a way that none of the chocolates go back to the original. सब गड़बड़ हो गया, सब यहाँ से वहाँ disarrange हो. तो this is can be also posed as a postman and letter problem. तो पोस्ट बॉक्स है, 10 पोस्ट बॉक्सेस है और 10 लेटर है. वो पोस्टमैन जी को कुछ पढ़ना लिखना नहीं आता है, शायद उसका चश्मा वो ये हो गया, So now he wants to put that. So he randomly puts the letters in different post boxes. In how many ways can he put the letters in the post boxes such that none of the post box में correct letter जाता है? अगर ये मैं क्वेश्चन पूछूं और ये जो चॉकलेट का क्वेश्चन पूछूं तो सेम है, तो उसका आंसर जो आता है वो ये आता है. इसका डेरिवेशन करने का मेरे पास वक्त नहीं है. इट इज n फैक्टोरियल इनटू दिस एंटायर एक्सप्रेशन. फैक्टोरियल क्या है बाय द वे? फैक्टोरियल इज n फैक्टोरियल मतलब n into n minus 1 into n minus 2 till 1. फॉर एग्जांपल 5 फैक्टोरियल क्या होगा? 5 into 4 into 3 into 2 into 1. ऐसा कम कम करते जाने का, मल्टीप्लाई करने का till 1. So 5 फैक्टोरियल इज 120. So 6 फैक्टोरियल कैसे रहेगा? 6 into 5 into 4 into 3 into 2 into 1. 6 तो 720 आएगा. So like that n factorial into this, ये पूरा एक्सप्रेशन का वैल्यू निकालेंगे तो नंबर ऑफ डिरेंजमेंट्स आपको आते हैं. ये डिरेंजमेंट प्रॉब्लम. अब ये n अगर बहुत लार्ज हो जाता है, n becomes larger and larger, then it has been found that ये जो एक्सप्रेशन ब्रैकेट में जो एक्सप्रेशन है, अगर n बड़ा लार्ज हो जाता है, so the value comes close to a number of 1 upon e, and e is this special number 2.71828. So एक अलग अलग कंटेक्स्ट में टोटली अनरिलेटेड, कहा हम लोग सोचेंगे कि भी नहीं कि ये ई का नंबर वहां पे मौजूद हो सकता है, वहां पे ई उपस्थित हो जाता है. पाई भी कैसे, आपको एरिया ऑफ अ सर्कल निकालना था तो आपको पता चल जाता कि पाई नाम का कोई नंबर वहां पे मौजूद होगा, उसका कोई सिग्निफिकेंस होगा. पर जैसे जैसे आप कोई भी पर्टिकुलर चीज को जनरलाइज करते हैं तो मैथमेटिकल थिंकिंग में जाते हैं, और मैथमेटिकल थिंकिंग करते वक्त ऐसे कुछ कुछ अजीब और अमेजिंग डिस्कवरीज होते हैं, जैसे ये ई का नंबर का डिस्कवरी हुआ. तो लाइकवाइज पाई का नंबर है. पाई का नंबर का आपने कहां पे सुना है? रेशियो ऑफ सर्कमफरेंस टू डायमीटर. कोई भी सर्कल लो, उसका सर्कमफरेंस मेजर करो, उसका डायमीटर मेजर करो, रेशियो हमेशा पाई रहेगा. ये एक बहुत अमेजिंग डिस्कवरी हमारे एंशिएंट इजिप्शियंस एंड मेनी अदर्स हैड डन. बट नाउ ऑफ कोर्स ये अप्रोक्सीमेट है. 22/7 जो आपको बताया जाता है कि पाई का वैल्यू है, वो करेक्ट वैल्यू नहीं है, वो अप्रोक्सीमेट वैल्यू. मे बी अप टू फ्यू डेसिमल पॉइंट्स करेक्ट है, उसके बाद वो गलत हो जाता है. करेक्ट वैल्यू ऑफ पाई is found by some infinite series. So रामानुजन साहब ने कॉम्प्लिकेटेड फॉर्मूला दिया है, वॉलिस फॉर्मूला यूज करते हैं, या फिर ये लाप्लास सीरीज यूज करते हैं, इनफाइनाइट सीरीज, उससे पाई का एक्यूरेट वैल्यू आता है. बट पाई हैज अ स्पेशल मीनिंग और अ स्पेशल प्लेस इन द वर्ल्ड ऑफ मैथमेटिक्स. नाउ ई का बात मैंने किया, पाई का बात मैंने किया. आई करके भी एक नंबर होता है, इट इज रूट ऑफ -1. इट्स कॉल्ड इमेजिनरी नंबर आई. So, जैसे हम लोग स्क्वायर रूट ऑफ ओनली पॉजिटिव नंबर्स डिफाइन करते हैं, लेकिन मैथमेटिशियन सोचे कि इतना क्यों रुकना है, वो तो रियल नंबर हो गया. लेट अस हैव एन इमेजिनरी नंबर सिस्टम वेयर i इज रूट ऑफ -1. सो हम लोग एक इमेजिनरी नंबर सिस्टम बनाएंगे जो i पर बेस्ड है, एंड i इज रूट ऑफ -1. एंड बाद में पता चला ये तीनों अलग अलग डिस्कवरीज है. ई का डिस्कवरी, पाई का डिस्कवरी, आई का डिस्कवरी, ये सब अलग अलग थॉट प्रोसेस से आया हुआ है. लेकिन अमेजिंग चीज देखो, मैथमेटिक्स की ब्यूटी क्या है, ये सब को कनेक्ट करने वाला एक ही इक्वेशन है. e raised to i pi plus 1 is 0 raised to infinity. 0 raised to infinity तो जीरो ही होता है, तो इसको आप सिर्फ जीरो लिखेंगे तो भी चलेगा, बट मैंने उसको थोड़ा सा और ग्लैमराइज कर दिया है बस, राइट? 0 raised to infinity. So 0 is the 6 great numbers of mathematics. 0, 1, infinity, e, I and pi. ये 6 के 6 connected by one equation of mathematics है. एंड ये सबका डिस्कवरी अलग अलग कंटेक्स्ट में हुआ था, लेकिन सबको कनेक्ट करने वाला एक ब्यूटीफुल इक्वेशन है, दैट्स कॉल्ड द गोल्डन इक्वेशन ऑफ मैथमेटिक्स. So therefore Proclus has said, wherever there is number, there is beauty. And mathematics is therefore not just about numbers or not just about calculations. It is about ideas and exploring abstract ideas, जिसका miraculously कोई real life application आता है, एक amazing immunity कहीं ना कहीं आती है. I'll give you more examples. But before that, one quiz. This is a quiz question. देखते हैं कितने लोगों को इसका आंसर आता है. थोड़ा सा डिफिकल्ट क्वेश्चन है क्विज का. Let me see how many of you can crack it. 2 days back I was 10 years old. Next year I will be 13 years old. Am I speaking lies? Not. How is this possible? अभी अनकॉमन सेंस से आप ये निकाल सकते हैं कि मैं झूठ तो नहीं बोल रहा. मैंने क्वेश्चन पूछा मतलब कुछ तो सच आंसर होगा. ये तो आप अनकॉमन सेंस से निकाल सकते हैं. तो चलो ऐसी बात है, तो हाउ इज दिस पॉसिबल, इसका आंसर बताइए. कैन एनीबॉडी गेस दिस? 32 दिसंबर को ऐसा कुछ होता है क्या? 32 दिसंबर, 31 दिसंबर, कैसे 31 दिसंबर? When did this conversation take place? And what must be my birthday? ये दो चीज आपको क्रैक करनी है, पजल को क्रैक करने की. लेट मी सी हु कैन गेट द आंसर. इन माय प्रीवियस वेबिनार 2 स्टूडेंट्स गॉट द आंसर करेक्ट. नहीं, लीप ईयर नहीं, नेक्स्ट ईयर मतलब नेक्स्ट कैलेंडर की बात कर रहे हैं, तो 29 फरवरी का फंडा मत लगाइए, वो गलत है, कुछ और है. Yesterday was your birthday. तो नेक्स्ट ईयर कैसे होगा? सोचो, आई एम गिव यू 10 more seconds, somebody answer it quickly. एक तो स्टूडेंट ने आंसर लाया, निकालना चाहिए. फर्स्ट जैन को क्या हुआ? कॉन्वर्सेशन हुआ. अच्छा, वेरी गुड. और बर्थडे कब है मेरा? 31st December. वेरी गुड. सो सम ऑफ यू हैव दोनों मिला के किया है. सो आई वाज स्पीकिंग ऑन 1st January and my birthday was 31st December. So 2 days ago I was 10 years old. Yesterday मतलब 31st December I became 11. This year is a new year because 1st January को बात कर रहे हैं. तो this year 31st I would be 12 and next year 31st I will be 13 years old. So ऐसा ये हो सकता है. So this is possible if this is the case. Are you getting it? तो इसमें लॉजिक आ गया ना, इसमें लॉजिक आ गया. तो ऐसा लॉजिकल थिंकिंग जरूरत है मैथमेटिक्स में बढ़ने के लिए. सो लॉजिक इज द बेस ऑफ मैथमेटिक्स. एंड फिजिक्स का बेस क्या है? मैथमेटिक्स है. केमिस्ट्री का बेस क्या है? फिजिक्स है. बायोलॉजी का बेस क्या है? केमिस्ट्री. ये सब इंटरकनेक्टेड है. पूरे टेक्नोलॉजी का बेस से सब पीसीएमबी सब्जेक्ट्स. Therefore, you should be good at logic, good at mathematics. उससे आगे हो. Talk something about geometry now because उसके बारे में आपको थोड़ा exposure है. I am sure you have heard about this Pythagoras theorem. Do you know how many ways humankind has discovered to prove the Pythagoras theorem? Pythagoras theorem क्या है? एक right angle triangle लेंगे, तो उसके जो दो sides रहेंगे. This is a place where is a right angle. Longest side को hypotenuse बोलते हैं. So a squared plus b squared is always c squared for any right angle triangle. ऐसा पाइथागोरस का थ्योरम. इसको प्रूव करने के बहुत सारे तरीके हैं. Any guesses how many ways to prove it? Mankind has found how many ways to prove the Pythagoras theorem so far? Published proofs कितने हैं इसके? Any guesses? एक proof? नहीं, बहुत सारे proofs हैं. 3 proofs? नहीं. 500. अरे बाप रे, very optimistic. 21 proofs. Okay, 367 ways exist. So far 367 different proofs of Pythagoras theorem are published. There may be even more than that, which probably have not been published. But out of this, we run a foundation program for our students for IIT Foundation in 7th, 8th, 9th level. So we generally teach them to prove it by at least 20 ways. So 20 different ways, which are not difficult, very logical, very simple ways to prove the Pythagoras theorem. इससे अपना दिमाग खुलता है कि एक ही क्वेश्चन को सॉल्व करने के अलग-अलग तरीके हो सकते हैं. Then you start having fun with the whole subject of mathematics and logic. So Pythagoras theorem इसको बोलते हैं. अभी Pythagorean triplets है. For example, Pythagorean triplets का मतलब क्या है? Triples बोलते हैं उसको. Triplets not necessary, but triples like 3, 4, 5. So 3 squared plus 4 squared is 5 squared. So it satisfies the Pythagoras theorem. So 3 अगर एक साइड 3 सेंटीमीटर, 4 सेंटीमीटर, 5 सेंटीमीटर का हो, तो ये Pythagoras right angle triangle बन सकता है. Likewise, any multiple of these Pythagorean triples will also be a Pythagorean triple. So 7, 24, 25, 5, 12, 13. These are some famous Pythagorean triples which are available. You should know this about this. ये Pythagoras theorem के साथ Pythagorean triples पता होने चाहिए. तो दिस इज जस्ट फॉर योर इन्फॉर्मेशन. आप शायद आगे के स्टैंडर्ड से पढ़ोगे पाइथागोरस थ्योरम, बड़ा नहीं होगा तो, लेकिन इसमें ये पाइथागोरियन ट्रिपल्स का कंसेप्ट काफी बार स्कूल में नहीं पढ़ाया जाता, तो ये आपको पता होना चाहिए. नाउ द मैरिज ऑफ अलजेब्रा एंड ज्योमेट्री. वेरी इंटरेस्टिंगली, रेने डेस्कार्ते करके एक फ्रेंच मैथमेटिशियन था. ही वाज लाइंग ऑन हिज बेड गोइंग टू स्लीप, बट ही सॉ सम फ्लाई मूविंग अराउंड इन हिज रूम. सो ही सेड कि इसका जो मूवमेंट है, इसको मुझे इसका एग्जैक्ट पोजीशन मुझे अगर बताना है तो कैसे बताया जा सकता है. So he thought of some idea where he can say we can have an x-axis, we can have a y-axis, and then we can have equations which can represent that fly on the coordinate system. You can have a 3-dimensional coordinate system x, y, z also. But later on he found out that there can be a way to connect algebraic equations with geometric figures. So connection between algebra and geometry and the marriage of both these subjects was conducted by this priest called René Descartes. That's why it's called a Cartesian coordinate system. Cartesian is after René Descartes, the name of this particular French mathematician. So essentially, x plus y is 3 का ये depiction है graph में. Y is 2x minus 6 का ये depiction है graph. Are you getting what I'm trying to say? So essentially, if you want to find the solution of this equation algebraically, अगर आपको difficult जा रहा है algebraically करने को, तो आप दो graphs draw करो और ये दोनों का meeting point जो भी है, that is the solution of this particular equation. This is true for anything. Like for example, यहाँ पे curve है, ये curve है, this will represent some kind of a complicated equation. This is a red color thing is another curve, it represents another complicated equation. But wherever they meet, this point of meeting, this point of meeting, these are two solutions to this particular equation. So sometimes when you cannot solve algebraic equations, you can draw them on the graph, and wherever they cut the x-axis or y-axis or cut each other, that is the solution of that particular thing. So ज्योमेट्री से अलजेब्रा का काम काफी बार इजी हो जाता है. काफी बार अलजेब्रा से ज्योमेट्री का काम आसान हो जाता है. So a big connection between algebra and geometry was built up by this René Descartes. So ultimately, you can see equations, you can visualize equations on a graph, and you can put down a graph or a geometric figure in the form of algebraic equations. दोनों का म्यूचुअल यूटिलिटी है, एंड कोऑर्डिनेट ज्योमेट्री नाम का एक ब्यूटीफुल सब्जेक्ट मैथमेटिक्स का बॉर्न होता है, जो आगे आप डिटेल में पढ़ेंगे, और इसका बहुत उपयोग है आगे आपके साइंस या टेक्नोलॉजी का पढ़ाई करने. Now I'll play a nice video for you. This is called a Mobius strip. How many of you, I don't know whether you heard about the Mobius strip. Mobius strip डिफिकल्ट नहीं है. आप अपना बेल्ट ले लो, कोई भी बेल्ट होगा आपको, या पीस ऑफ पेपर होगा, उसको आप बेंड करो और थोड़ा सा ज्वाइन करते हो, ट्विस्ट करो. मतलब नॉर्मली जो दो एंड ज्वाइन होने वाले थे, उसको ज्वाइन ना होते हुए उसको ट्विस्ट करके ज्वाइन द अदर टू एंड्स. दैट्स इट. एक बेल्ट को एक ट्विस्ट लगा के रिजॉइन करोगे तो वो मोबियस स्ट्रिप बनता है. मोबियस स्ट्रिप का प्रॉपर्टी क्या है? इट इज द ओनली स्ट्रक्चर with only one edge and one surface. So इसका उदाहरण आप देख लीजिए इसमें. You can see this here. Look at these ants. Okay. So you see the ants are never crossing any edge. They're just going around like that. This entire Mobius strip, this is called a Mobius strip. It has only one surface. This is a unique property. There are various amusement parks, maybe ऐसा होता है, but this is, look at it once more. Follow any particular ant. एक ant को देखो कैसे जा रहा है. You will see that it is only going through one side, but going inside also, outside also. It never crosses the edge. Normally आपको inside, outside अलग अलग होता है, but here it is just one. This is called a Mobius strip. इसके भी applications आगे science and technology में होते हैं. There are Mobius circuits which are there, which have amazing properties in electronics. But anyway, this is just for your information. Now look at this one more thing. This is a problem of tessellations and tiling. Normally कोई flat surface अगर आपको दिया, तो if you see a floor, any flooring देखो, tiles देखो, अगर regular pattern के tiles है, तो इधर rectangles रहेंगे, squares रहेंगे, equilateral triangles रहेंगे, या hexagons रहेंगे. Hexagon मतलब six sided polygon, regular polygon. So only these four figures, plane figures, have the property that if you keep repeating them, the complete tiling happens. आप अपने washroom के tiles भी देखिए wall के, या आप अपने flooring के tiles देखिए, कोई भी जगह पे आप जाते हो देखिए, you will see that either they are squares or rectangles or triangles or hexagons. There is no other shape possible to tessellate or to tile the entire surface with regular patterns. Interestingly, on a spherical surface like a football, I don't know how many of you love football, but how many of you have closely observed the football? Football को आप आपस देखिए, या आपके रबर बॉल को आपस एक बार देखिए क्रिकेट का, और वॉलीबॉल को या बास्केटबॉल को, जो भी आप खेलते हैं, you will see that it is impossible to stitch these portions जो होते हैं, they cannot be all hexagons. Like here you will see these are black ones are all pentagons, and there is a hexagon connecting them. Only then you can tessellate a complete spherical surface. So spherical surface को tessellate करने के लिए, this is called tessellation theory or tiling theory. आगे आप पढ़ सकते हैं डिटेल में. So any of the spherical surfaces को, curved surfaces को tessellate करना है, so you will require different types of figures. This is also an interesting fact. It's called general topology नाम का एक फील्ड है मैथमेटिक्स में, इसमें ये सब चीजें आती है. बट ये एक इंटरेस्टिंग चीज है. अगर आप फुटबॉल अच्छा लगता है आपको, many of you love to play basketball or cricket, then you should know that if you observe that ball properly, you will see that these different portions which are stitched together to make this ball, they are never all hexagons like on a flat surface. You can see all hexagons on a flat surface, but on a spherical surface you have always hexagons plus pentagons. Keep that in mind and observe that next time you touch a football. Now I'll play one more interesting thing. There's a 4-color theorem. I want you to see this particular video. I'll just play that video for you. Give me a moment. Yeah, this is the video.
Let's suppose you started working for a map-making company and you're given the unfortunate task of coloring in the blank maps. Your aim is to color in the country such that no two adjacent countries share the same color. Otherwise, someone reading that map wouldn't be able to distinguish between those two countries. So you might want to color this blank map by giving each country their own color. This works, but your boss might not appreciate the rainbow map. In fact, if the United States of America were colored this way, things would be difficult to read, and in practice, actual map makers, known as cartographers, tend to use the least number of colors as possible. So we begin to color in another map with the least number of colors. In this case, it took only 3 colors. Suppose we're given a third map, this one a little more complex. This, however, only needs 4 colors. Notice that these two countries are not adjacent because they meet at a point and thus can be colored the same color despite being different countries. Let's do another one. This map needs to be colored with 5 colors. However, coloring the map a little more strategically, you can see that it only needs 4 colors. This brings us to the 4-color theorem. Essentially, it states only 4 colors are required to color any map such that no 2 adjacent regions have the same color. Now you might
Interesting, isn't it? So there are, if you see this world map also, you will see that there are only 4 colors needed to complete the map. So that no 2 adjacent regions or countries will have the same color. So this is called a graph theory का ऐसे एक interesting result है 4-color theorem. तो ये ऐसे बहुत सारी चीजें हैं जो logically, mathematically इस चीज को derive किया जा सकता है. So this is not something which is just based on your calculations. It involves ideas. And ideas are important. Now, there is one more interesting application of mathematics to art, to designers, those who love to create things visually beautiful, even those who are musicians, people who love music or who love to compose music. There is a certain perception of beauty or melody which is there in these different domains, right? So you have visual beauty, you have audio, and in terms of audio, we talk about good music quality, good timbre, and good melody. So therefore, uska connection bhi mathematics se hai. So if you see, there is something called as a Fibonacci sequence, and this you will find everywhere in nature. Number of petals of a flower, the number of branches of a particular tree as it grows. Mostly, not always, but mostly it conforms to what is called as a Fibonacci sequence. Now, what is a Fibonacci sequence? You have, let's say, number 1, number 2. The next number of the Fibonacci sequence you can generate by adding the first 2 numbers. So 1 plus 2 becomes 3. Then 2 plus 3 becomes 5. 3 plus 5 becomes 8. So just by adding the previous 2 numbers, you get a number. And you start with 1 and 2, and then you generate this entire sequence, which is called as the Fibonacci sequence. Now, if you were to divide any 2 consecutive numbers, let's say divide 13 by 8 or 21 by 13, as you can see here, you get these ratios. This ratio, you will see, starts progressing towards a special number called 1.618. This is called the golden ratio. This is a very interesting thing. कि golden ratio, जैसे अभी आप screen देख रहे हो, आपका mobile phone है या laptop है या TV screen है, the ratio of the length of the screen and the breadth of the screen, generally to make it look aesthetically pleasing, will always be 1.618 का ratio रहेगा. हमेशा कोई भी आप पेंटिंग देखते हो तो पेंटिंग का लेंथ एंड ब्रेथ का जो डायमेंशंस रहते हैं वो दे ट्राई टू मेक इट क्लोज टू दिस 1.618 रेशियो बिकॉज़ इट हैज बीन फाउंड दैट ये 1.618 गोल्डन रेशियो इज अ वेरी स्पेशल रेशियो. और ये रेशियो क्या है? इट इज द रेशियो व्हिच कम्स बाय डिवाइडिंग एनी नंबर ऑफ अ फिबोनाची सीक्वेंस बाय द प्रीवियस नंबर. So as you go larger and larger numbers, this number becomes more and more accurately to 1.618. So it infinite sequence है भाई फिबोनाची का. तो फिबोनाची सीक्वेंस, अभी आप कोई भी पेटल्स ऑफ अ फ्लावर, अगर आप कोई फ्लावर लो उसके पेटल्स गिनो, you must not have done this exercise ever, but you actually count the number of petals. More often than not, you will find that the numbers of this Fibonacci sequence में से कोई तो एक number होगा. So nature also prefers this Fibonacci sequence. Number of branches of a tree, even the ratio of the different parts of our body. If you see the entire height of a person and if you measure it from the head to the torso, वो ratio भी काफी बार 1.6 के आसपास रहता है for most humans. And wherever there is a sensation of beauty, something aesthetically pleasing is seen, this golden ratio, this Fibonacci sequence is there. So people who are artists, people who are designers, who design different things and paint, they are also aware about this golden ratio, and many of the designs are done around the golden ratio to make it look attractive or appreciate it better. Even in music, there is a whole theory of composing music using Fibonacci sequences and the golden ratio. And such amazing music comes out. Even in fact, some of the famous Western classical pieces of Beethoven, Mozart, and many others, they have seen that this golden ratio has played a role there. So I leave it to you now to discover more about the Fibonacci sequence and the golden ratio. So you can see that even if you see games that you play, the tic-tac-toe, you play the Rubik cube, you play this, these are magic squares. So arrange the numbers in such a way that all the rows add up to one number, all the columns add up to the same number, all the diagonals add up to the same number. This is magic squares. But there is a very mathematical way to generate magic squares. ऐसा तुक्केबाजी से नहीं आता है. इसको generate करने के लिए भी there is a complete theory of mathematics called group theory. इससे use करके इसमें ये सब किया जा सकता है. Now, how to play such games like tic-tac-toe in such a way that you will always win? There's some mathematics branch called game theory, which will have a certain set of rules and 2 players are, let's say, playing it, then how to basically play in such a way, what strategies can always make you win. ये सब के लिए game theory of mathematics है. So ये सब चीज का काफी बार होता है. Actually, I studied in IIT Bombay. At that time, this Rubik cube was very famous, but we actually studied this from a mathematical standpoint. And then me and my friend, we wrote a computer program for any n by n cube, not just 3 by 3 cube, any n by n, 10,000 sides by 10,000 का भी होगा तो चलेगा. To make an n by n cube, and how can the computer solve that cube? How can what set of moves will ensure that you crack this Rubik cube? उसके लिए एक proper mathematical algorithm है using linear algebra and group theory. Easy है वो, difficult नहीं है. But for that you need to know mathematics. Otherwise you will see this as a very great game and you will try all kinds of stuff and try to get it. But abhi now, if you know mathematics, then you can actually crack this by the most efficient number of moves. Secondly, you can also design different designs on this Rubik cube, not just all sides having same color. And which designs are possible, which designs are not possible, this can all be told if your mathematics is strong. So there are a lot of mathematical theories in it. That's why I always say mathematics is about ideas. It's not just about understanding or calculations and some concepts. It's about ideas. Keep that in mind. It's about creativity and keep with new ideas. जैसे अभी उन्होंने बोला imaginary number. किसने सोचा था imaginary number की बात भी होगी? But imaginary number also has found applications. अभी आप घर पे बैठे हो, घर पे कौन सा सर्किट चल रहा है आपका? ये जो स्विचेस, लाइट्स, फैन सब चल रहे हैं आपके, कैसे चल रहे हैं? इलेक्ट्रिसिटी से चल रहे हैं. कौन सा करंट आता है? डीसी करंट या एसी करंट आता है? ऑल्टरनेटिंग करंट आता है, एसी सर्किट. आई थिंक फिलीपींस इज द ओनली कंट्री इन द वर्ल्ड वेयर डीसी सर्किट चलता है. बाकी दुनिया में सारे कंट्रीज में एसी सर्किट ही चलता है. एसी सर्किट का एनालिसिस अगर करना चाहोगे तो आपको इमेजिनरी नंबर्स यूज करना पड़ता है, कॉम्प्लेक्स नंबर्स. उसके बिना नहीं होता वो. So some very amazing places you will find applications of these weird concepts of mathematics is all I'm trying to say. But mathematics may sound, as I said earlier, it may sound complicated, but actually it makes complicated things simple. And it finds amazing applications in different domains. See, this is Ramanujan's magic square. It's a very famous square. Its beauty ये है कि सारे like any other magic square, all rows will add up, all columns will add up, diagonals also will add up. In this case, it adds up to 139. But not just that. If you take any 2 by 2 square out of this also, it will add up to 139. This is the beauty of Ramanujan's magic square. So Ramanujan was a great intuitive genius, and he has developed this magic square, which has got this property that even the 2 by 2 part of it, if you take out of this magic square, it turns out to be the same number 139. This is a unique magic square named after him. Ramanujan's magic square is called. Now let me present to you some of the biographies of some of the greatest mathematicians. There have been amazing number of mathematicians with great brains, did amazing work. But I would like you to know about at least 3 mathematicians and what they did. This number E मैंने जो आपको कहा, it is called Euler number after Euler. Euler was perhaps the most productive mathematician, the most prolific mathematician the world has ever seen. He has contributed over 1,600 original results. And let me tell you, as for motivation's sake, the last 13 years of his life, last 13 saal of his life, he was almost blind. And despite that, out of 1,600, almost 350 results out of 600 were given by him to the mathematical world when he was almost blind. See, almost a blind person could contribute 350 original results in mathematics. As human beings having all things right, can we not at least understand what these people have done? Please tell me that. So human brain has such extraordinary potential. This can be seen by Euler's work. He is the only mathematician in whose honor there are 2 numbers named. One is this 2.7828 wala E number. And there's one more number by the name 0.5771. It's called Euler constant. ये थोड़ा higher mathematics में आप पढ़ते हैं. F plus V is E plus 2. ये मेरे ख्याल से result आपने school mathematics में शायद पढ़ा होगा. I learned this in school when I was in 4th standard. If you take any regular solid, number of faces of that solid plus number of vertices will always be number of edges plus 2. Any regular, आप रास्ते पे जाइए, stone उठाइए. Pick up any stone, not the muddy one, the sharp stone, proper stone होगा. उसके देखिए add the number of faces, add the number of vertices, मतलब vertices मतलब जो small points जो add होते हैं जहाँ पे edges, and find the number of edges मतलब straight lines connecting that. You will always find F plus V is E plus 2 for any regular solid on this planet. You cannot generate any regular solid which violates this particular rule, at least in real space. Imaginary में वो भी होता है, non-Euclidean Eulerian solids भी होते हैं, वो अलग बात है. So golden equation is also referred to as Euler's equation. आपको जो e raised to I pi plus 1 is 0 raised to infinity बताया, it was discovered or proposed by Euler. ऐसे ही बोलते हैं. So something very prolific you should know about this great mathematician. Srinivas Ramanujan, of course, the most intuitive mathematician ever born. इनको तो सरस्वती माता की स्पेशल कृपा थी। सवेरे उठते थे, कुछ तो रिजल्ट उनको दिमाग में आ जाता था, it just used to dawn like an intuitive flash. He used to just write it down. He would not know whether it is correct or not. Sometimes he would see a formula as a dream and he used to just pen it down. So essentially, this is some very interesting stuff he did. I already spoke to you about 1729 as a special Ramanujan number. But many of the results of Ramanujan are yet to be proved. Even he himself could not prove many of his results. But the result is true. Work karta hai. And especially now in the world of computers, the last 20, 30 years, in number theory, and number theory ka extensive use is being done for crypto, for cyber security, blockchain technology. ये सब आजकल जो आप cryptocurrency, Bitcoin वगैरह सुनते हैं, is all based on blockchain technology, which is a part of cryptology and cyber security part. उसमें for coding part, to make something keep the secrecy there are a lot of number theory algorithms used, जहाँ पे रामानुजन के बहुत सारी theorems का अभी उपयोग आजकल हो रहा है. Some of them have not been proven till date, but they are of great use. Interesting, na? Ramanujan has contributed, for your information, 3,900, more than Euler also. Something amazing. But most of his work has been in number theory. Euler ki beauty kya thi? He has contributed to diverse areas, not just of maths, physics also. Friedrich Gauss, I think he started with mathematics is the queen of all sciences. Because Gauss, he's hailed as the prince of modern mathematics. He invented differential geometry. Now let me ask you a question. From Euclid geometry, आपने पढ़ा होगा. Sum of the angles of a triangle कितने होते हैं? How many degrees होते हैं? बताइए. Sum of the angles of a triangle कितने होते हैं? 180 degrees. Correct. But ये differential geometry जो गॉस साहब ने इन्वेंट किया था, जिसका उपयोग आइंस्टाइन ने अपनी थ्योरी ऑफ रिलेटिविटी के लिए किया, आपने सुना होगा E is mc squared of Einstein. वो प्रूफ करने के लिए he had to use differential geometry, non-Euclidean geometry. उसमें sum of the angles of a triangle is not 180, it is something else, sometimes greater than 180, sometimes lesser than 180. ऐसा सब कुछ होता है. So this mathematics was developed by Gauss. He's considered one of the prince of modern mathematics and has done groundbreaking work in a lot of fields of mathematics and also in physics. There's a law called Gauss's law of electrostatics named in his honor. So one of the very big brains of mathematics ever. So you should at least know these three names of mathematics and their contributions. If you're going to study mathematics in the future, if you're going to be studying science in the future, or even if you're studying economics and finance in the future, you must know about these three mathematicians, because आगे आपको mathematics से बिना कुछ करने को होगा नहीं. That's why these are the three biggest apostles of mathematics. Okay. My point is this. Logic, mathematics, physics, physical chemistry, organic, inorganic, this is all interwoven. Mathematics is nothing but applied logic. Physics is applied maths. Physical chemistry is applied physics. Organic, inorganic is applied physical chemistry. And biology is ultimately applied chemistry. तो ये सब interconnected है. तो आगे अगर आपको इन फील्ड्स में कुछ भी करना है, तो ये बात समझना पड़ेगा कि आपको मैथमेटिक्स के साथ फ्रेंडशिप करनी ही पड़ेगी. अदरवाइज फिर आप साइंस छोड़ दो, या इकोनॉमिक्स एंड फाइनेंस आपकी बस की बात नहीं है, फिर आपको कुछ जिंदगी में कुछ और करना पड़ेगा. और अगर और भी कुछ करना है तो उसका कहीं ना कहीं कोरिलेशन मैथ से तो जुड़ा रहेगा, ये बात आप भूलना नहीं. Let me ask you a quiz question. Please answer this quickly. I'll give you 10 seconds. In what parking spot number is this car parked? Give me the answer quickly. Okay, one answer is right. Ishan has got it correct. Okay, no, okay. हाँ, तो ये 87 आएगा. Correct. So 86, 87, 88, 89, 90 और 91. अगर आप इसको upside down देखते हैं तो आपको पता चल जाएगा क्या है. It's just a small visualization puzzle, nothing else. Okay, good. Now let me talk about IITians Prashikshan Kendra. Basically, my point was simply this. If you have understood different facets and aspects of mathematics, I wanted you to appreciate that mathematics is a lot more than calculations in what you have studied in school. And it's full of ideas and creativity, and it has wonderful applications across. So keep exploring, keep studying mathematics. And if you go back to your books now and go back to studies mathematics from different perspectives, which I tried to give you today, I'm sure you will appreciate this subject better, score better, and your confidence in this subject will become better. And you'll see mathematics everywhere. So our institution, IITians Prashikshan Kendra, I'm representing this institution today. We have basically coaching students for IIT entrance exams, JEE advanced and stuff. We also coach students for medical entrance exams. You want to be a scientist, a mathematician, an engineer, a technocrat, you want to get into these premier engineering colleges or science colleges, our institution has a lot of programs for you from standard 7th, 8th, 9th, 10th, 11th, 12th onwards. So every year we have been producing ranks in the IIT exam. We have contributed a large number of almost 1,200 IIT ranks we produced in the last 20 years. This is almost 1/3 of the entire Pune city ranks. So every year we have been getting a lot of ranks. We have coached more than 10,000 students in the last 20 years. 2,500 plus national college selections. These are the names: ICERS, IISc Bangalore, NICER Bhubaneswar, Atomic Energy College Mumbai, Chennai Mathematical Institution, India's finest institution for mathematics research, Indian Statistical Institution. We have been sending students to all the premier colleges with a very high success ratio of 22% for IITs and an excellent success ratio for other colleges as well. We have also been bagging a lot of admissions for medical experience as well in the last so many years. Last year also our students did exceptionally well. 117 of them got an IIT rank, and students cracked all exams despite all the COVID-related challenges. So we have been getting very good success ratio and retention ratio year after year in Pune. So we are a leading coaching institution, and the Times of India Group has awarded us repeatedly for 4 consecutive years as the top coaching institution for engineering entrance exams. We have 3 programs basically which I would like you to know. If you are going to 8th or 9th, we have a Prodigy program which will teach you for all maths, physics, chemistry, and biology, and some coding, and all fun activities like Rubik cube solving, chess workshop, astronomy workshop, automobile workshop. All this is wrapped up in this fun to do program called Prodigy. So if you're interested, you can definitely talk to us. And if you, after 11th and 12th, if you want to pursue medicine, you can do this top doctors program. Want to pursue engineering, you can do this 2 years rigorous grandmasters program. So we offer this program in online and offline mode both. This is basically our roadmap. If you're in standard 8, you can either do this Prodigy Juniors program for physics, chemistry, maths and science. But if you're a maths buff and you want to get into the international Olympiads, training आपको करना है, maths Olympiad को deeply करना है, then there's a Maths Whiz program for training you for the regional maths Olympiads and the international maths Olympiad. आपको पता होगा कि जैसे Olympic games होते हैं, वैसे maths के भी Olympic games होते हैं. It's called international maths Olympiad. Every country से 5 students are representing the country. So to select those 5 students, there is a huge 5-step process. So regional maths, so pre-RMO, RMO, ऐसे 5 stages government ने बनाए. So to coach you for that, we have this Maths Whiz program, both for 8th standard as well as for 9th standard students. If you're interested, you can definitely consider that. So I was talking about the Maths Olympiad ke 5 stages. These first three stages is coached by our institution, but the next 2 stages are done by the government of India only. It's called the IMO, the International Maths Olympiad Training Camp, and then the pre-departure training. So till the 3rd stage, pure India se around 30 students are selected. And then finally 5 students represent the country, and then you win gold, silver, bronze, whatever. So essentially these first 3 stages के लिए Maths Whiz का program हमारा होता है. ये every Friday को होता है, online होता है Zoom पे, and 6 to 9 p.m. in the evening होता है, and we coach students for pre-RMO, RMO, INMO, and the IOQM examination, which is for Maths Olympiads. So this is a 6-hour per week session for 8th and 9th standard students. If you want to do mathematics deeply, then this is there. If you want to just study maths and science so that you will be trained for future exams and to improve your scores in school as well as for different competitive exams like Homi Baba and NTSC, etc., then we have this Prodigy Juniors and Seniors program. It's a 10-month program starting from May to March, every Sunday and Thursday. You can definitely inquire more to know more about this particular program. They're very interesting programs where we teach maths and science in a fun way. At the same time, give you a lot of knowledge which is required for school and beyond school. Right? So essentially for your future competitive exams and for your future fundamental building, all this activity is done. So you're welcome to us. If you want to know more about us and about these different programs, feel free to connect to us at this number or visit our website or email us at info@iitpk.com. Let me tell you a couple of more things. These were all, of course, paid programs, but there are some free services, social service initiative IITPK does. You can join our YouTube channel called IITP Classroom or subscribe to our Telegram channel called IITPK. These channels have a lot of free information which we share for IIT Foundation and for the basics of physics, chemistry, maths. Already 100+ lectures we have floated on IITP Classroom already. They teach you the basics of maths, physics, and chemistry, and also biology. So if you are interested, you can always subscribe to these channels for free and keep getting a lot of knowledge and understanding about the science and maths from us. So I hope you have got a fresh perspective for mathematics, discovered, understood, appreciated some unknown facts about mathematics, which are interesting, and probably your interest in the subject may have been kindled. And if that has happened to some extent, I would consider my talk as productive and useful. Otherwise, anyway, questions, I'm now open. I'm throwing the session open for any questions that you may have. Thank you very much, Athos Solutions and all schools, principals, coordinators, and students for arranging this particular talk. Thank you very much.
Yeah. Thank you very much, sir.
Yes.
I hope the students like the session and will definitely love to have the questions. Students, you can put the questions in the chat box. So I got one question.
Sure.
Mathematics. Why mathematics is required if our target is to go for MBBS?
See, mathematics is required because in your medical entrance exam, which is NEET after 12th standard, you have physics, you have chemistry, and you have biology. And I told you that chemistry is applied physics and physics is applied maths. So to understand physics, you will need a lot of mathematics. If you open out the 11th and 12th standard NEET level books of physics, you will see that उसमें English कम है और maths ही ज़्यादा है, diagrams and equations ही ज़्यादा है. So maths समझेंगे नहीं तो physics समझेंगे नहीं. फिजिक्स नहीं समझेंगे तो फिजिकल केमिस्ट्री भी पूरा मैथमेटिकल है, वो भी नहीं समझेंगे. तो ह्यूज अमाउंट ऑफ योर नीट एग्जाम का वेटेज का पार्ट 720 मार्क्स का नीट एग्जाम होता है. 720 में से एटलीस्ट 350 मार्क्स 300 टू 350 मार्क्स इज डिपेंडेंट डायरेक्टली ऑन मैथमेटिक्स. तो अगर आप मैथमेटिक्स बिल्कुल ही नहीं पढ़ेंगे तो आप वो मार्क्स लूज आउट करेंगे. और सिर्फ फॉर्मूला सब्स्टिट्यूशन के क्वेश्चंस नहीं आते, कंसेप्चुअल आते हैं जहां पे कुछ इक्वेशंस लिखने पड़ते हैं, फॉर्मूला डिराइव करना पड़ता है. तो ये सब के लिए जरूरत है. नंबर 1. नंबर 2, ये मत समझिएगा कि बायोलॉजी का मैथ से कोई संबंध ही नहीं. फॉर एग्जांपल आप डीएनए सीक्वेंस देखिए, डीएनए में जैसे अभी आजकल कोरोना वायरस का भी बात होता है, स्पाइक प्रोटीन आ गया, इतने सारे म्यूटेशंस हो गए. ये सब कहां से कैलकुलेट करते हैं लोग? ये काउंट नहीं करते. There are a finite number of permutations, combinations that the protein molecule will be there in a particular virus or whatever. तो उसको कैलकुलेट करके एस्टिमेट करके बाय लिस्टिंग, they don't have to list down all the possibilities. Mathematics use करके बहुत सारी चीजें की जा सकती है. आगे there is a complete field called bioinformatics. There's a complete field called genetic engineering. It's based on all this kind of genes work. उसमें mathematics काफी है. अगर आप बायोकेमिस्ट्री भी करते हो तो बायोकेमिस्ट्री में भी काफी सारा फिजिक्स एंड मैथमेटिक्स आ जाता है. कैलकुलेशंस उसमें भी इन्वॉल्व है. So don't think that these are all subjects to just mug up by heart and stuff like that. ऐसा rote learning से कुछ फायदा नहीं. आपको by heart करने की जरूरत ही नहीं है. After 12th standard, Google is available for information. Calculators are available for calculation. Then what the human mind is for? Human mind is for understanding concepts and applying them and giving new ideas and creativity. Creativity के लिए, ideas के लिए, concepts के लिए, concepts के application के लिए, उसके algorithms develop करने के लिए human mind है. Calculation can be done by any machine. Information will be there on Google or some book that you can always refer. You don't have to keep things in mind. So very importantly, you should understand that ये आपको MBBS बनना है, अच्छे डॉक्टर बनना है, तो डॉक्टर को भी लॉजिकली सोचना पड़ता है. अभी now there is IBM has developed one supercomputer algorithm called Dr. Watson. So if you feed the symptoms, it will give you exactly the diagnosis. It does better than most doctors in the world. There was one very rare disease which was to be diagnosed, and it was given to 23 topmost doctors in the Asia Pacific region, in the Japan, Australia, China region, to the top 23 topmost doctors. None of them could crack that, thinking ये symptoms के वजह से this problem must have happened. But then Dr. Watson को भी वही case history medical report submit कर दिया. So that computer algorithm could actually find the correct diagnosis. इसको exactly क्या illness हुआ? It was a rare illness. And then when the actually doctors discovered and tested further, they found out that he was right. So point is that there is a logical process towards diagnosis, and once diagnosis happens, then the prognosis can happen, treatment can happen. So therefore, ये सब के लिए mathematics या physics या logic या logical thinking इसका उपयोग रहता है for all doctors. नहीं तो फिर वो कुछ भी हो गया तो फिर उसको यही मेडिसिन दे दो, फिर वो यही इंजेक्शन दे दो, इससे बहुत गड़बड़ हो जाता है. So therefore, अच्छे डॉक्टर्स हमेशा लॉजिक यूज करते हैं और उनका एक्सपीरियंस और ये सब चीज के काम होता है. So don't ignore this subject. You don't have to study too deeply. Don't have to study too deeply, but आपको उसके बेसिक्स का ज्ञान होना चाहिए, बस इतना ही.
Sir, the rule of 72, is it only applicable on compound interest or anything else?
नहीं, compound interest. Compound. For different thing you can develop new rules, but उसके लिए थोड़ा काम mathematical work करना पड़ेगा. But rule of 72 specifically is for compound interest. Compound interest का concept क्या है कि the rate of growth of something कैसे डिपेंड करता है, वो एक ज्योमेट्रिक सीक्वेंस से आता है ना, वो उसका बेसिक.
Right. Sir, why 1729 is a magical number?
पता है ना, रामानुजन नंबर का बात किया ना. It is the smallest number expressible as sum of two cubes into different ways. पता है था ना, हार्ड रामानुजन नंबर का एक स्लाइड था, तो we discussed 1729 के बारे में already.
Right. So there is a question which, if you permit, I would like to answer. UPSC one. Why mathematics is required in UPSC? Any UPSC exam you people write, any UPSC exam, whether it's NDA, it's IAS, it's CDS, it's IES, or any other exams like forest exams hote hain and all, mathematics is the main ingredient of these exams. आपको मैथ्स का पेपर क्रैक करना ही होगा. अगर आपको आईएएस बनना है, आपको आईपीएस बनना है, और आपने एग्जाम के लिए अप्लाई किया उसके, तो आपको जो पहला पेपर आएगा, जो प्रिलिमिनरी पेपर होता है, उसमें आपको इंग्लिश, जीके और मैथमेटिक्स ही आने वाला है. और आपके 10th और 12th स्टैंडर्ड के मैथमेटिक्स पे ही ये सारे पेपर्स बेस होते हैं. सो यू कैन नॉट स्किप मैथ्स in any of the subjects. As sir has said very clearly, mathematics is logic. So if your logic is not clear, आप कहीं पे भी जाके कुछ एक्शन ले नहीं पाओगे. अगर आप एक आर्मी ऑफिसर बन गए एंड यू आर गोइंग ऑन वॉर फील्ड, और आपको मैथ से नहीं पता, अच्छा कितने दूर से गोली चलाऊं, कितना सेफ डिस्टेंस रखूं, कितने दूर से रेकी करूं. अगर आप एक सिविल इंजीनियर बन गए, तो आप जो आपका मैथ्स है, अगर आपको उसका लॉजिक ही नहीं पता है, तो आप लॉजिक को यूज ही नहीं कर पाओगे, तो आप अपने फैसले कैसे कर पाओगे. So mathematics is required in all these examinations. And अभी आप 7th 8th में है, so अभी से आप ज्यादा लंबी चीजें ना सोचें कि आप यूपीएससी एग्जाम क्रैक करेंगे एंड ऑल क्रैक करेंगे. अभी इस राइट टाइम है कि यू कैन जस्ट मेक श्योर दैट यू स्ट्रेंथन योर मैथ्स एंड योर लॉजिक. So that will help you in next 2 to 3 years. So when you pass 12th, you start appearing for these exams. By that time, you'll be very much clear with all those things. Sir, there is a question. A child is asking a question again and again. Sir, how mathematics is used to solve Rubik cube?
कुछ नहीं, वो तो एक स्पेशल अरेंजमेंट है ना. तो बेसिकली देयर इज अ कांसेप्ट कॉल्ड मैट्रिक्स. मैट्रिसेस होते हैं. मैट्रिसेस करके कुछ तो एक मैथमेटिकल डिवाइस है, आप बाद में पढ़ोगे. तो देयर इज समथिंग कॉल्ड मैट्रिक्स अलजेब्रा. उसमें सर्टेन ऑपरेशंस होते हैं. तो आप एक पर्टिकुलर ऑपरेशन करते हो दैट करस्पॉन्ड्स टू वन पर्टिकुलर पैटर्न ऑन द रूबिक क्यूब. So once you know how the Rubik cube moves, उसके हिसाब से there are certain rules for the matrices के operations के लिए that can be set and that can be fed into the computer. तो initially configuration क्या था, वो matrices के initial numbers डालने का, that numbers will correspond to different colors, to different parts of the particular stuff. और फिर उसके operations अगर well defined हो mathematically, तो there is a certain algorithm which can be mapped. उसमें कुछ mathematics के थोड़े deeper laws पता होने चाहिए. And you can map it. You can write a computer program based on it. We wrote a program for n by n cube, not just for 3 by 3. Any कितना भी बड़ा क्यूब बनाओ और वो उसका कोई भी कॉन्फ़िगरेशन दे दो, उसको वापस राइट साइड में लेके जाएगा और कंप्यूटर ही करेगा वो. We don't have to do it. And computer will tell you in how many moves it did, what it did to get to that particular point वगैरह. So it is a mathematically solvable puzzle. सिर्फ अपने को मैथमेटिक्स उतना आता नहीं है, इसलिए जब वो टॉय करके अपने को मिलता है, then we fiddle with it and we feel something amazing is there and we have to work it out. It is of course interesting. As a kid, I also did it. I also tried it out, and sometimes with success, without success, and later on with trial and error only we did it. But then we understood कि अरे mathematically अगर उसको देखा जाए तो फिर ये तो बहुत easily किया जा सकता है. और उसमें से क्या कौन सा पैटर्न संभव है, कौन सा नहीं है, ये भी मैथमेटिकली इजीली डिसाइड किया जा सकता है. सो मैथमेटिक्स इज अबाउट जनरलाइजिंग पर्टिकुलर थिंग्स इनटू अ स्ट्रक्चर. देयरफॉर आइडियाज बहुत इंपॉर्टेंट है, ये समझना.
Sir, how and why mathematics is useful in cyber field?
अरे बाप रे, साइबर फील्ड के सारे जो कीज होते हैं, पासवर्ड, सिक्योरिटी प्रोटोकॉल्स होते हैं, उसमें बहुत नंबर थ्योरी के थियरम्स यूज किए जाते हैं. बहुत सारी चीजें यूज की जाती है जिसके वजह से अभी वंस अपॉन ए टाइम, अभी नहीं होता आजकल, लेकिन आप क्रेडिट कार्ड या डेबिट कार्ड देखिए आपके पेरेंट्स का. ओके, वो जो क्रेडिट कार्ड नंबर है या जो डेबिट कार्ड नंबर है ना, इट यूज्ड टू बी अ प्रोडक्ट ऑफ टू प्राइम नंबर्स, ऑलवेज लार्ज प्राइम नंबर्स. एंड देयर वाज नो मेथड, मैथमेटिकल मेथड कि आप एक लार्ज प्राइम नंबर लो और उसको if it was a multiple product of two large prime numbers, then you could not factorize it easily. There was no mathematical method available. अभी आज के तारीख में अवेलेबल है, late 90s में वो डेवलप हुआ एक मेथड, इसलिए now they are no longer using this algorithm. But from 80s to 90s जो भी क्रेडिट कार्ड, डेबिट कार्ड नंबर्स जनरेट होते थे across the world, they were always product of two large prime numbers. So why it was like that? Because it is not possible to factorize it like that. ऐसे बहुत सारे theorems हैं, तो उसको इस्तेमाल करके, वो रिजल्ट्स को इस्तेमाल करके, there are some what you call cyber locks, cyber keys are generated, and therefore mathematics तो wholesale level पे यूज होता है. अभी आपने बिटकॉइन माइनिंग सुना होगा, there are Bitcoin होता है cryptocurrency में, और there are some different new coins are mined. ये mining process क्या है? By solving a hard mathematical problem. तो मैथमेटिकल प्रॉब्लम को सॉल्व करके ही माइनर्स बनते हैं, और वो सॉल्व करने के लिए इट इज नॉट पॉसिबल टू सॉल्व यूजिंग आइडियाज, सो देयरफॉर दे नीड लार्ज कंप्यूटर्स, एंड वो बहुत बड़ा जगह खरीदते हैं, बहुत बड़ा कंप्यूटर्स का फार्म बनाते हैं, सर्वर फार्म बनाते हैं, एंड देन इट इन्वॉल्व्स crores of rupees to be invested, and then they solve a tough mathematical problem, and then they are able to mine a bitcoin. So ये बहुत क्लोजली रिलेटेड है. तो आपको गेमिंग अच्छा लगता होगा, आपको सोशल मीडिया में मस्ती करने को मजा अच्छा लगता होगा, ये सब सुपरफिशियल है. आप डीप डाउन जाओ, मैथमेटिक्स ही मिलेगा आपको.
Sir, what is the use to solve algebra? Just a minute. The question just vanished. I'll just ask it again. What is the use to solve algebra and find x? Will it be ever useful in our life?
या माय डियर, अभी आपको उसका मतलब समझेगा नहीं, आपको लगेगा बोरिंग है, टीचर पढ़ा रहे, ट्यूशन टीचर पढ़ा रहे, पेरेंट्स फोर्स कर रहे हैं, लेकिन दैट एक्स कैन बी एनीथिंग, इट्स अ फ्रीडम, इजंट इट? आप जैसे जैसे आगे जाओगे, जिंदगी को अनुभव करोगे, यू विल सी सम रियल लाइफ प्रॉब्लम्स. टू सॉल्व दैट प्रॉब्लम, sometimes by mapping that situation as an equation or as a graph or as a mathematical object or a model, उसका solution निकलता है. ऐसे इतिहास बताता है, especially last 300-400 years का history ये बताता है कि very difficult real life problems are solvable by using some mathematical tools. उसमें ये x, y, z ये सब यूज होता है. बड़े कभी क्रेजी लगे, एब्स्ट्रैक्ट लगे, बोरिंग लगे कि इसका कोई जिंदगी से संबंध नहीं है, बहुत संबंध है, बहुत गहरे संबंध. ये थोड़ा आगे 2-4 साल के बाद आपको ज्यादा उसका समझ में आएगा, एहसास होगा, इतना. लेकिन फिलहाल मेरे शब्दों पर विश्वास रखिए, बहुत यूजफुल चीजें हैं.
Right. Sir, if we want to become a doctor and our preference is purely biology, then what do you suggest in 11th standard? Should we take PCMB?
नहीं, 11th-12th में आपने मैथ्स ड्रॉप भी किया तो चलेगा. मेरा वो कहना नहीं है कि आपने 11th-12th में मैथ्स लेना चाहिए. मेरा सिर्फ इतना कहना है कि आप मैथ्स का पढ़ाई करिए ताकि फिजिक्स केमिस्ट्री समझे. You can drop maths, it's okay in 11th and 12th. I'm not saying you should take maths as a formal subject, but you should study mathematics is all I'm saying, so that physics, chemistry, biology can be done. This is all I'm saying. Because without mathematics fundamentals of certain chapters, you cannot do anything in physics, you can't do anything in chemistry. ये मैं क्या, केमिस्ट्री मतलब एटलीस्ट फिजिकल केमिस्ट्री में तो कुछ भी नहीं कर पाओगे आप. ऑर्गेनिक इनऑर्गेनिक थोड़ा बहुत आप कर पाओगे, लेकिन उसमें भी अगर आप डीपर क्वेश्चन आ गया ऑर्गेनिक में, तो उधर भी मैथ्स घुस जाता है, फिजिक्स घुस जाता है, फिजिकल केमिस्ट्री आ जाता है, काइनेटिक्स उधर भी आ जाता है ऑर्गेनिक में भी. तो यू कांट डू, इट्स ऑल इंटररिलेटेड, इंटरकनेक्टेड.
Right. So what is quantum?
अच्छा, आपके जेब में कितने पैसे हैं अभी? या चलो आपके पेरेंट्स के जेब में कितने पैसे हैं, कितने नोट हैं, देखो. कैन यू गिव मी 213 rupees 66 पैसे राइट नाउ, या टू एनीबडी? 233.66 पैसे नहीं, चलो 233.67 पैसे दे दो, या चलो 244.13 पैसे दे दो. दे सकोगे कैश में? नहीं ना. तो क्वांटम ऑफ मनी और करेंसी इन इंडियन थिंग इज 50 पैसे. 50 पैसा होता है क्या सौम्य आजकल, मिलता है क्या, देखा तुमने आजकल? क्या
सर
1
जमाना
रुपए
हो
का
गया.
आधा जमाना
जमाना
हो
हो गया.
तो अभी 1 रुपए
जमाना
पे
हो गया.
कोई मांगेंगे, तो 1 रुपया इज अ क्वांटम ऑफ इंडियन करेंसी. तो द स्मॉलेस्ट यूनिट बाय व्हिच यू कैन डील, अभी स्मॉलेस्ट यूनिट ऑफ एनर्जी को प्लैंक्स कांस्टेंट का h म्यू बोल देते हैं, वो 10⁻34 तक जाता है. तो क्वांटम ऑफ समथिंग एल्स का कुछ और होगा. तो क्वांटम ऑफ इंडियन करेंसी कैश सर्कुलेशन इज 1 rupee कॉइन, इज 1 rupee. तो आपको जो भी पैसा होगा, यू कैन ईदर गिव मी 266 rupees और 267 rupees. You cannot have anything in between. So the quantum of money is 1 rupee. ऐसा. तो क्वांटम हमेशा लगता है मोमेंटम मेजर करना है, एनर्जी मेजर करना है, एंगुलर मोमेंटम मेजर करना है, मास मेजर करना है, टाइम मेजर करना है. तो देयर इज अ क्वांटम. फॉर एग्जांपल अभी आपका जो क्लॉक होगा आपके, इफ यू आर यूजिंग एनी वॉच और क्लॉक होगा आपके घर पे, उसका क्वांटम ऑफ यूनिट क्या है फॉर मेजरमेंट ऑफ टाइम इज 1 second. तो जो भी टाइम आप बोलेगे, so many hours, so many minutes and some seconds तक बोलो. If you have a stopwatch, maybe it will go up to milliseconds or microseconds or nanoseconds or picoseconds or femtoseconds or attoseconds. So depending on what the granularity of that device is, least count of the devices. The point is, quanta is the least unit, the smallest unit, but you can always multiply that by an integer to get the subsequent units. तो आपको रुपीज चाहिए तो 1 रुपए के ही मल्टीपल में मिलेगा कैश, आपको अदरवाइज नहीं मिलेगा। आर यू गेटिंग व्हाट आई एम ट्राइंग टू से? सो क्वांटम उससे आता है। तो उन्होंने क्या डिस्कवर किया कि एनर्जी इज नॉट कंटिन्यूअस, energy is always available as a integral multiple of some basic unit. It's called quantum. So this was an amazing discovery because everyone Newton, everybody thought कि अरे नहीं ये तो energy तो continuous flow जैसा ही रहता है। जैसे अभी पानी है आगे, there's a gardener who is watering the plants, वो पानी तो ऐसे continuous water stream जैसा ही जाता है ना hose pipe से, तो it is like a continuous stream of water. But अगर मैं machine gun से bullets of water से gardening करूँ तो bullets of water will come. So there are discrete number of bullets called quantum. तो बेसिकली डिस्क्रिटाइजेशन जब हुआ, सेपरेट यूनिट्स अगर आने लगे तो उसको क्वांटम बोलते हैं। अगर कंटिन्यूअस आ गया तो फिर उसको क्वांटम नहीं बोलते। दैट इज बेसिकली द होल स्टोरी। तो एनर्जी इज क्वांटाइज्ड है, एनर्जी क्वांटाइज्ड है, मोमेंटम क्वांटाइज्ड है, मास क्वांटाइज्ड है। ये सुन के सारे साइंटिस्ट थक एकदम ये हो गए, शॉक हो गए इन द अर्ली पार्ट 100 years ago। तो उससे क्वांटम फिजिक्स नाम का एक अलग फील्ड आ गया। वैसे क्वांटम कंप्यूटिंग भी उसी से आता है।
Sir, I guess we have taken all the relevant questions.
Okay.
So one last question: what is the use of statistics in daily life?
है ना, अभी आप तो ये भी खेलते हो, क्रिकेट देखते हो, फुटबॉल देखते हो, वहां पे सब वो प्लेयर्स के सब स्टैटिस्टिक्स आते हैं, उसका एवरेज इतना था, उसने इतना किया, अच्छा स्कोर, हाईएस्ट स्कोर, उसका लोएस्ट स्कोर इतना था, फिर इतने सेंचुरीज मारे, इतने से किए, या वो फुटबॉल में इतने सारे गोल्स किए, इतने सारे ग्रैंड स्लैम जीते, टेनिस में कुछ तो आता है ना। आप चेस खेलते हो तो आपको तो कितने सारे स्टैटिस्टिक्स आप जो देख रहे हो वो स्टैटिस्टिक्स का ही तो करिश्मा है। जो एवरेज है, मीन है, मोड है, ये निकालना है, ये सब स्टैटिस्टिकल एनालिसिस से ही आता है। ऑफ कोर्स ये बेसिक चीजें हैं, लेकिन आगे चल के बहुत सारी, जब फॉर एग्जांपल अभी कोविड कभी चल रहा है, लास्ट 2 साल से पैंडेमिक कभी आ रहा है, तो पैंडेमिक का कर्व आगे पीछे कैसे जाएगा, ये भी स्टैटिस्टिकल एनालिसिस से कुछ मैथमेटिशियंस एक्यूरेटली प्रेडिक्ट कर पाए हैं काफी हद तक। आई एम नॉट सेइंग वेरी एक्यूरेटली बट टू अ रीजनेबल एक्सटेंट। सो ये भी स्टैटिस्टिक्स से ही होता है। देयर इज अ फील्ड कॉल्ड स्टैटिस्टिकल प्रोबेबिलिटी। भी वेदर फोरकास्टिंग होता है, कैसे हो रहा है? There's a Karmarkar algorithm. I don't know whether you're aware about it. There's one more great mathematician of India. He was an All India rank 1 in IIT 1974. Narendra Krishna Karmarkar. He's right now in India. We had a good fortune of teaching his son. Vivek Karmarkar was our student for 2 years. Right now he's studying in IISER. He has developed this Karmarkar algorithm. Karmarkar algorithm across the world is used for weather forecasting models. वो लीनियर प्रोग्रामिंग बेस्ड है, लेकिन वेदर फोरकास्टिंग के काफी सारे चीजों में स्टैटिस्टिकल एनालिसिस भी यूज करते हैं along with various other algorithms. बहुत ये सब सारे मैथमेटिक्स के अलग अलग फील्ड्स को इस्तेमाल करके बहुत सारी चीजें किए जा सकते हैं। तो जस्ट हैव फेथ दैट व्हाटएवर यू स्टडी इज नॉट यूजलेस, इट्स वेरी यूजफुल, बट इसका उपयोग कब कहाँ क्या है ये बाद में पता चलता है, इतना ही।
Okay. Sir, we'll wind up today's session.
Thank you.
And sir, एक बार आप वो नंबर एक बार वापस फ्लैश कर दीजिए।
हाँ जी, हाँ जी। अच्छा, मुझे और एक उनको क्वेश्चन भी पूछना है, बाद में छोड़ना है उनको। तो ये हमारा नंबर है, और लास्ट क्वेश्चन में एक पजल में छोड़ के जा रहा हूँ, एक इंटरेस्टिंग पजल व्हिच आंसर आई विल नॉट गिव फॉर यू टू डिस्कवर। दिस इज आवर नंबर इफ यू वांट टू कनेक्ट टू अस।
Anyone who wants to attend such more sessions, they can contact this number directly.
Correct. Okay, now this is one puzzle from our side to you, and that is this. You can take a screenshot of this and keep thinking. Thank you so much.
Thank you, sir. Thank you very much for this wonderful session. Thank you all the schools, all the students, all the teachers and coordinators for encouraging the students to join, and thank you students who stayed with us for so long. Any other questions you have, you attend more sessions, the number was flashed. You can go and contact them directly and you can attend it.